my friend?
Well, it's somewhere here.
Hang on, let me find it.
It's got GPS location.
Oh, did we get a photo?
Yeah, I know where they are on the map, but we're just gonna find somewhere here.
Since opening our campus 150 years ago, we have constantly evolved from our first pioneer. Since opening our campus 150 years ago, we have constantly evolved from our first pioneers in gender equality. We have inspired a new generation of leaders. If we saw closed doors, we'd be first to burst through them. As we have evolved the world around us, helping our students reach new heights. We have given shape to the laws of nature and the nature of our laws. We have helped preserve ancient languages while breaking new ground with the written word. Although we are proud of what we have achieved, we remain resolutely focused on the future. By continually becoming the change we wanted to see, the University of Adelaide has evolved into one of the world's leading universities. Because by making history today, we will build the world we want for tomorrow.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People travel from far and wide to see this new city. We call it Moon Valley. The Moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
One of them was like exercise. It's not our exercise, but it consists of an Oscar. So the first aid dummy. So one of our members was like, hey, is that an Oscar? And then our dealer heard it. There's a casualty over it. What do you do?
Oh no!
So we took that Oscar, carried it all the way to the base.
Wait,
and then the
what,
other
Oscar
team-
was just lying there, and it wasn't
No,
part
it
of
was
the
part
activity.
of the activity.
Oh, it was, okay.
But we took it.
Oh! It was part of a different activity.
And then we had to bring it back. It was fun. We all hate Oscar. It's so good to not be wanted.
Ooh, very updated.
Simon, do you need help?
Let's go. Let's go, Pat.
Come on.
You are skilled and trained in this.
They don't even need it. I was doing something. I was looking up.
Oh, you got another shovel? Where? Ah.
Use your hands.
We need to try and find something, and I did find it. Oh, UW would have started at 8:45, but they pulled out, so Atlas started and then.
Oh.
Okay, readable.
It's up there.
Oh, I just found it. Okay. QT4, nice. Epic hospital. Oh, Project Scorpio. Oh, Project Scorpio is in front of me. Almost 7 points.
Damn. Yeah.
60, 62 meters.
That's a big difference between QT is 4.
Yeah.
And then finally, there's the presentation. So the details of that kind of breaks it down by
Yeah.
presentation and I'll come and you present that
Got a new grade
at
up.
the conclusion of the class.
Yeah, I'll help you pack it down.
Have any questions? Otherwise,
I'd probably do another one. Oh.
So on Thursday night, we put these.
We watched your guys' video last night. You guys have done really well. I was impressed with how fast and nimble it was. It was brilliant.
Let her rip.
Is that 6 minutes? Yeah. Good. Totally part of it.
It's fun to be on this side too. Less stress. Yeah, right? I remember science class in 2018 having been up
Okay, so you can turn on your antennas and start moving your rover onto the pitch.
I'll be there. Yeah, no worries. Big time.
Oh wow.
Wait, what?
Thanks, James.
That's you.
Wait, you're going what? Oh, oh, it is.
Why not? So, you guys are able to move the rover onto the
Pretty cool.
Got all of them?
আমি অটোনমাস কিচ্ছু পারি না সকাল 5:30টায় উঠাই দেয় উঠো তোমার অটোনমাস কাম আছে আমি মেকানিক্যাল ইলেকট্রিক্যাল আর ডিজাইনিং তিনটাই দেখছি 4 নম্বরটাও ধরাই দিল আমারে
অনেক কঠিন ভাই এর মধ্যে আমার তুলতেই পারে না ও আধার ভাই
আমি বুঝলাম
Beautiful sunny day down here in Roseworthy, South Australia. G'day, my name is Daniel Ricardo, and we are sitting here at the beautiful Roseworthy campus, hosted by University of Adelaide. And as a reminder, welcome to day 4, the last day of the Australian Rover Challenge, and boy, what a cracker it's been. So again, as a reminder, today is the Boeing Mapping and Autonomous task. This challenges the teams to get their rover to be navigating autonomously across the lunar surface, trying to navigate to key areas of interest and to identify objects that us, the judges, have told them to go find. And again, rovers must do this autonomously. So this requires the teams to be hands-off, no interaction, except press start and go and let it rip. So as a reminder, today, there are 100 points available. First, in Activity 1, this involves allowing the teams to simply descend down that ramp. And again, it may sound simple, but getting your rover to descend down a highly steep ramp with no safety barriers means that there is a lot of issues associated with making sure that your rover can navigate itself autonomously by itself down that ramp, get those first 5 points. And then activity number 2, 30 points for landmark navigation. Now this is involving the rover to navigate around the lunar surface and try and identify some images and text to relay to us, the judges. And this is trying to get the rover to figure out image detection. And tell us its coordinates. The higher accuracy their coordinates are in a map they give us, the more points they get. And lastly, of course, as we did with yesterday's iSpace Space Resources task, we will do a presentation. Now, this just involves a 10-minute discussion with us, the judges, about validating how they implemented their systems and also how the data they collected is valid and what sort of format they gave us the map and why the map. Thing to design a really robust system as an engineer or to do a research project, but if you can't communicate that effectively, there's almost no point in doing it, because again, all the beauty of these projects need to be communicated effectively, and that's what we're trying to do with these presentation tasks, to get them to practice those communication skills and become well-rounded future employees. And again, we are training the future workforce right here, and these are the real tasks that they will have to compete in if they decide to go further into the Australian space industry or the space industries associated with their host universities and home countries. And the view right now of the base station team of Team Atlas, all the way from Bangladesh, their first debut task here for mapping and autonomous, and their first debut at the Australian Rover Challenge. And again, this is our 4th year, growing each and every year, really expanding the number of teams and also the growth of the teams, the amount of students per team. So it's great to see that as we continue to grow, so do these teams. And as a reminder, in that little picture-in-picture there is the Team Atlas Rover. Almost a complete redesign from day one, post-landing, brought to us by the Australian Space Agency into day 2 on Friday, the ELO 2 excavation and construction task. And that rover, you can see, it used to have 6 wheels. It used to have a main chassis. It was quite heavy, and they did a complete redesign almost overnight into this zippy, lightweight, fast system that has enabled them to snag a lot of points. And it's great to see that rapid innovation, that rapid pivot, making sure that they can adapt to the rule set, adapt to the challenges. And this is exactly the problem solving that we're going to need when we go to the moon, because nothing always works. Everything always breaks down. It's that essence of Murphy's Law. If something can go wrong, it will go wrong. And let's see how the team battle it out here. Again, if they get any movement autonomously out of that initial start gate, then points are theirs. And as a reminder, the time is 9:33. Their official start time was 9:30. And these tasks go for a total of 40 minutes. And for those wondering, tuning in back home, RMIT at 10:15, Adelaide at 11, Melbourne at 11:45, QUT at 1 o'clock, UQ Space 1:45, 2:30, Project Scorpio, the current reigning #1 podium finish with a hell of a lead. And 3:15, Monash Rover, followed by an award ceremony at 4:30, and we hope you tune in for that as we get to award not only the winners, but we do have some movement of the rover across the surface. And it's great to see that not only have they managed to set up their rover, it is moving. And I've said this so many times over the previous days, the fact that their rover is moving is a testament and culmination of so many intricate interweaving systems. So every movement, every action should be really celebrated. And again, they've got so much time to keep innovating, so many years to keep coming back and getting better. And again, you can see those that rocker suspension. So rocker just meaning 2 wheels on a single pivot point, that rocking ability, those large wheels, inbuilt suspension, springs in that X fashion, tires duct tape to those rims. And again, we've seen a lot of duct tape and zip tie across all the rovers, and that's really the bread and butter of any good engineer. Now those rocks that the rover is saying hello to, again, there are penalties out for colliding with the props and infrastructure. Now this is trying to get the teams to understand that if they were to deploy their rover on the surface of the moon, it takes a lot of money, it takes a lot of time and practice to send pieces of infrastructure up there. So a lander, a comms tower, radio tower, you don't want rovers hitting those, which is why we provide a 10-point penalty for any collision. So if you see a rover about to collide, this is why we see some teams with obstacle avoidance built in, and they can use this, they can achieve this using either stereo cam or LiDAR. LiDAR being it shoots out spectrum of light and it bounces back and it gets some depth, and then stereo is 2 offset cameras providing a bit of depth by comparing the 2 images, similar to how our eyes work. So if you close one eye, you really struggle to get that depth of perception, which is why we see in stereo.
whatever all the data use, and also collect data to then put in a presentation for us.
And again, the view there, just a big red button to the bottom left. If you're wondering what exactly that is the emergency stop. This is a mandate requirement that we have on all rovers, ensuring that if anything goes wrong, either us, the judges, or the field team can go press that button to make sure that the rover doesn't injure itself, but more importantly, it doesn't injure anyone else out here today. And again, you can just see how quick this rover is traversing across the surface. It's one of the quickest rovers we've seen, making light work of this lunar simulant.
I've got a hat. UV still just below 3, so I'll sort that once these guys are done in a minute.
And that view of the base station team right now deliberating how they're going to keep tackling this challenge. And as a reminder, each team is split up as they compete into a field team and a base station team. The field team responsible for making sure that no serious damage occurs, and they're the only ones that can hit that E-stop. And again, the base station team, their job is to traverse and navigate using the rover and then call for either an intervention, which is a 10% penalty to all their task, where the field team jump into action and do some critically needed repairs, or newly added to this year's competition is the reposition, which allows rovers where their mobility system has become non-functional to reposition the rover across the field, allowing them to keep attempting a task even if some critical infrastructure goes down. However, that's a 40% penalty to the remainder of the points for that task. And just to the left there, you can see that blue block. Now, these are the things that it needs to go out and find, but not only find, it needs to maintain its reference frame for where it is out on the surface. And they get points by providing us, the judges, the XY coordinates of those blocks in a localized map that the rover tries to figure out and map itself from that start gate. So really a difficult task to try and showcase the difficulties associated with localizing. Now, why does a rover need to do this, you may ask? Well, on the moon, there's no GPS, there's no Wi-Fi, there's no 4G. The surface is extremely difficult to navigate at varying scales because craters can exist from several tens of kilometers down to a few centimeters or sub-micron, because there's no atmosphere, which means all the dust and debris out there in the solar system has been slamming into the surface of the moon for billions of years, creating what we call lunar regolith, that extraterrestrial soil that covers the surface, giving it that grey texture, but also making it extremely difficult to figure out where you are, at what scale you're looking at on the surface of the moon. And this is something that the Apollo astronauts commented. They didn't know if there was a giant hill or if it was a mountain over the horizon. And again, the moon being smaller, that horizon really messing with the depth perception and distortion view of the astronauts. And as we saw yesterday, depending on the angle of the sun on the surface, you can get some really unique shadows and textures or some really significant illumination and reflections coming off that bright sand back into the cameras of the rover team, making the use of LiDAR especially really tricky in the sun, but also Stereocam. Those shadows do provide a little bit of texture, helping the cameras figure out what distance things are away from it, helping it plan out that pockmarked crater surface on the pitch today. And the rover's spending a lot of time around this initial block, perhaps trying to determine where the block is, where it is in relation to the map that it's trying to create. And again, if you're using various things like wheel odometry, which just means how many times is the wheel spinning, and then you can calculate how far it is from a certain point. But that gets really tricky because on a flat surface, if you were driving your car out on the road, sure, that works. But out here on the surface where you've got lots of slip, the sand is loose and really tricky to get constant contact the wheels with the ground, which means that you have so much error accumulating every single time that you move, every single time that you turn. All those errors keep stacking up. So using wheel odometry is really tricky, which is why other teams use various other things like trying to map out where it is, where it has been, and always reiterating using a point cloud from the LiDAR, from the stereo, any data set you can get, any independent data sets you can compare against, making sure that the data set you have is robust across multiple different variables, really critical to help these mapping and autonomous tasks.
I guess you have to just cross the rate and I guess.
That's how we said, and we had
There's no other point.
Do you know if you got 5 marks?
We don't know actually.
You don't know. No, that's fine. Okay, that's fine. We thought the plan would be like 7 but yeah, because we thought it has to be 6 meters because we thought the box would be 6 meters, so we need to go forward 6 meters. But okay, that's fine.
Maybe your boat has to take the direction from here. That's why they tell that from here and to here, the boat will go 6 meters from the right direction. And then
So this rover really making full use of the field, traversing all across. And again, they do get points for operating either autonomously or non-autonomously, so there could be a little bit of manual control. You can see the base station team there using that controller to navigate around the field. As long as they can provide us coordinates of those blocks across the field, they can get points. But again, it's the trick. How do you localize yourself not only as you're exploring and you're mapping, and this is simultaneous mapping, commonly called SLAM, simultaneous localization and mapping, which is the trick of how do you figure out where you are in three-dimensional space. And again, on the surface, all that loose material just really making it difficult for two reasons. One, to make sure the mobility system works so that you don't get stuck. But two, so that you know where you are at a varying amount of scale. And again, just to sense of that scale, you can see how tiny that rover is compared to the huge mounds we've got out here. A brand new feature for this 4th year of the Australian Rover Challenge. In the past, we've been limited to a smaller field, but not out here at beautiful sunny Roseworthy in South Australia at the Roseworthy campus of the University of Adelaide. We've got a brand new 35 by 30 metre pitch with obstacles up to 1.2 metres. You can see those huge 3 hills protruding out of the back of the arena. And again, those 3 props that you see to the front. To the far right, you've got the lander, and this is the lunar lander that we use across varying tasks that the rover has to descend down. Acting as the start gate, you've got the solar array sitting in the middle, and then the processing plant to the bottom left, and the comms tower hidden away, tucked away behind that hill on the back right. And if you have really good vision, you can see on each of these supply caches, there's going to be a little status readout, and what the rover had to do on the first day of the challenge, the post-landing task, was read out these statuses to us, the judges, to be awarded points. Now, this is testing that the rover can, 1, navigate across the surface, but 2, use its cameras to relay information. So if your rover can, at a minimum, drive and see, it can get a lot of points across all the tasks, and we do this intentionally so that new teams can really secure themselves a seat in that upper bracket of the leaderboard. Keep the simple things simple. Don't overcomplicate things. If you can drive around, if you can see, you can get a lot of points. And that's what the team today is demonstrating now. Their mobility system making light work of this arena.
প্ল্যাকার্ড কোনো দিন তাহলে ওইদিকে ওরা ঘুরতে যাবি ওইদিকে যদি পারি না সেটা তো আমি কোনো প্ল্যাকার্ড দেখি আচ্ছা স্ক্রিনে এখন ওই
oh, what's his name? The guy that like lends us the beer.
On the screen right now, that white block. So one of the various colored blocks that the team needs to navigate to and localize. And again, on the screen to the right and left, those wheels held together with duct tape taped around that rim with that inbuilt suspension, quite unique. And again, the Bangladeshi flag, a very proud team. Great to see that really lightweight, rapidly innovated Rover zooming across the surface. And you can see some of the cameras it's using, that GoPro mounted to the top. Some webcams also mounted. And it's just trying to navigate across this surface, localize and build up that map. The more times it can traverse around and try and localize itself, maybe the higher resolution or higher accuracy can get these XY coordinates to tell us where those blocks are out on the map. And as a reminder, how do we know where those blocks are? Well, Cyro has kindly helped us to map the surface in extreme high detail using LiDAR. Over 300,000 data points being collected almost every second. And you can see these incredibly detailed, including color, three-dimensional maps generated using LiDAR.
I've seen this exact problem as well, and it ended up being the LiDAR was falling out of the LiDAR was falling out of the plugged into the USB hub, plugged into the Jetson Nano, the Jetson whatever Jetson, and the hub was like just barely too weak to handle the bandwidth. And that's when like data started dropping. So they were getting a flickering, like the view will start flickering, the data dropping. Yeah, I know. So then it's the next candidate is like, is it a power issue? Is it misbehaving? Because we don't have that thing. I don't think we found the barrel jack. Yeah, but that's the thing, right? Did that actually work? Is now my question. Okay, let's do it. I should
And just behind the Rover, you can see that ELO 2 sponsorship, and it was great to see the tech demonstration by that team yesterday out here on the pitch. That little Rover, 20-kilogram Rover, as part of the Australian Trailblazer mission. One of the consortia, the other one being a Rose out from Western Australia and across Australia. They're building rovers to be sent to the moon, but of significance, these are entirely developed and built within Australia, Australia's flagship mission to the moon, and we've got to see the ELO 2's attempt to showcase that rover going in great success, being controlled from the United States, traversing across the pitch that we've got out here today, the exact same pitch as these undergrad and graduate students. So great to see this demonstration and collaboration of students and industry, creating or at least demonstrating that pipeline. And again, they did mention a lot of the students with experience at the Rover Challenge having internships or current jobs with these consortia. So really demonstrating the pipeline we're creating here at the Australian Rover Challenge for Australia's future workforce. And not only that, the future workforce of the global space industry, as we've got some international competitors up on the screen right now, Team Atlas from Bangladesh, of course, and Project Scorpio from Poland, currently sitting at a very comfortable #1 podium lead. And you can see on the screen right now that rocker suspension, the inbuilt spring suspensions for each wheel, helping distribute some of that load. That novel plastic tub chassis, GoPro cameras, electronics built in. That emergency stop, of course, critically required to make sure that if anything goes wrong, we can end all power across the system to make sure that no electrical fires break out, but also, more importantly, that no damage to the rover subsystems occur, so that the rovers can continue to compete across the challenge, across all of the tasks. And we do require that each rover can be, 1, safe carried, 2, has that emergency e-stop, 3, has those LED lights alerting everyone when the rover is powered and when it is moving, and must conform to size and mass constraints depending on which task it's in. Now, the size constraints, 1.6 meters in either direction, and mass, depending on which task, does vary a little bit. And a view right now of the base station team using all that data they're getting from the rover to control the rover. And again, the only information they're getting is collected and sent from the rover to their base station antenna. Everything I say they can hear because they're nearby. But this is just trying to showcase the requirements of a mission control operating a lunar rover out on the surface. So the team's still traversing across. Now the e-stop being hit, looks like. And just as a reminder, in terms of schedule today, so Team Atlas going from 9:30 to a potential 10 past 10. RMIT coming up at 10:15, so we may have a bit of a break. Then Adelaide, Rover team at 11. Of course, Adelaide being part of the host university here, making this competition viable. Uni Melbourne at 11:45, QUT at 1 o'clock, UQ Space at 1:45, Project Scorpio at 2:30, and Monash Rover at 3:15.
prepare the field to really nominate both the base station and the field trainings that you are ready to. We will get you some radios that you'll be able to
So the team have pressed the e-stop, meaning that the task time for Team Atlas has ended. Let's give them a round of applause as they've carried the Rover off. And again, congratulations to Team Bangladesh for their debut here at the Australian Rover Challenge. And we really thank you for coming out here, showcasing what you've got and making a lot of rapid decisions for that chassis, the redesign, overnight. And again, as a quick reminder of schedule, so coming up next, we've got RMIT at 10:15, followed by the Adelaide University Rover team at 11 o'clock. Uni Melbourne at 11:45. A bit of a break until QUT at 1 o'clock. UQ Space at 1:45. Project Scorpio from Poland, the current #1 podium finish, at 2:30, followed by Monash Rover at 3:15. So it'll be a very interesting matchup tonight, as a lot of these teams have spent all hours last night trying to test, validate their systems, getting them working out there on the pitch autonomously. And it's great to see that the teams are putting so much hard work and effort into these Rovers, really trying to showcase what they've done and what they've been able to do over the last year of development. And we really wish them all the best. But I'll let you have a little bit of a break now as we tune back in for RMIT to start at 10:15. Thank you very much.
So you're pretty confident for driving finally, although I'm also pretty confident because of that. And you've searched through that? Yeah, well, I'm dig at this point.
Your base station setup time has started. You place the rover in the starting box, sorry, which they see the origin is marked with the green and the red stakes on the ground just next to the lander, and then you can start anywhere in that box, which is not really working with the line. So you go one down the side, the rest of the box is marked out with the blue and the yellow shells. There's one there. Any So didn't have box already. Collisions with obstacles in autonomous or non-autonomous mode will attract attention. Not including the Yep. But because you're 1.6 meters long, you're going to have to either be facing that way or facing that way. And maybe it's trying to get like this. As long as it's in that box. Oh, no. Right, we ready? So you guys can't move the rover onto the starting point. Yeah, as long as there's no
We can have that with you.
No, no.
We can just, at the end of it, grab the USB.
You might.
I'm in no rush.
Oh, I have no idea.
If another camera is pointing to this, yeah, only one program. And it's
Okay, so now, so sorry, so, let me reset the field for that.
Hi.
On there.
Getting like, he's just being like, oh, with the robot the other day.
Hi there. I got it. Let's go with you. ওখানে আর কি আছে ভাই লক হয়ে গেছে তো কি পাসওয়ার্ড ধরেন ব্যাগগুলো রাখবেন ব্যাগগুলো কি টাকা তো টাকা না
I'm not software.
I see. Yeah.
So there's that.
Okay, cool.
Can we not just set up right there?
How?
That's some badges.
It's hard.
Start right on the
Okay, so
what's the strength?
no, because what's hard is the so you know that you've got those plates on top of the bar hole. He wants to know the position of that relative to the origin of that at the start. So that should be
Start right there.
yeah. Like if we press the wheel, could we press it
Like,
up right?
they've got so many. We could do. He wants more. Center of back right here. So square. And then they just like this.
Like you.
So if the wheel's like this, it's like this the wheel.
Oh, yeah.
Like facing that way, you put it on the middle of the gear. So you're like, I think red jack, your X would be 0, Y would be whatever. And then you just measure and pad from that point. Your X, Y, and both to Mark. Up to because it's really difficult to tell what a backwards is.
Yeah. Unless you put up like a right angle.
You could have it like the Rover fully inside. You put the square on the bed It depends where you go. Otherwise you just memorize it. Let me go.
Oh no, not this one.
Oh, it's the other way.
Yeah.
I don't know what you mean. Like, why are all your vlogs so specific? I don't know.
Just say the name. Yeah, but the stars are like the stars are like weird. Yeah. Oh no, we're looking at that.
Dan? No. Sorry? Does anyone Can you compare them on the location? Yeah, that's the we could probably do that. How much is we should probably just look and see how that plays. She's my baby, I'll have you.
Look at the starting square. Yeah, that's what I was saying.
Yeah,
it's like, nah.
We can't do change.
Excavate all the sand off. Okay.
And get levels of local.
Copy that.
what I was going to say was maybe forming like of people who know what's wrong, like how
I'm good. How are you?
So that requires people's partnership.
I'll see you come around the side. The reception is so bad, you're just cutting out the bars.
Competition band and practice band.
There you go, Michelle. What's up? Yeah, I'm good. All right, thank you.
Yeah.
Was it the one? Didn't get it right.
Where's the we set it up?
Oh, it's like she's over there with the team.
Yeah.
Have they done it other days?
Lunar surface. Yes, and we're back. Hello. So the time is 10:20. RMIT setting up their rover for their attempt at the Boeing mapping and autonomous task. And again, their official start time was 10:15, so they've still got 35 minutes available to them. Lots of time to troubleshoot, try to get those first 5 points for leaving the start gate. And as we can see right now, the view up on the base station, that base station team setting up, communicating to the field team during this initial setup, and we give teams lots of flexibility because as we've seen over the last 3 days, lots of things can go wrong. There's lots of complexities associated with setting up your system, making sure those communications are working, making sure the motor controllers are working. There's no shorts, that the electronics are all communicating. There's no loose cables. The code is all running and optimized because, as we can see here out on the field as judges, we're the first ones to arrive, last ones to leave. All the teams are working furiously on the off time, making quick changes to their system. And again, under those duress situations, making quick changes. If everyone isn't across, lots of systems can go wrong. But so far, all the teams are making huge leaps in the abilities of their rover, and the time up on the screen, 33 minutes left on the clock, any current local time. And boy, is it a beautiful day. Not a cloud in the sky. We've had some excellent weather out here at sunny Roseworthy in South Australia, brought to you by the University of Adelaide. And what a spectacular field we have out here today. 35 by 30 meters of lunar surface. This premier world-class analog facility, already the host for over 10 university rover teams, including, as we saw yesterday, following the ELO 2 excavation and construction task, ELO 2 being one of the consortia building a rover for the Australian Space Agency's contribution to the NASA Artemis program. What do all those words mean? Well, we are returning to the moon, and this time to stay, and Australia's contribution to that global mission is a Foundation Services rover, and that's exactly what we're trying to provide here at the competition. We're trying to provide the future workforce so that we can meet the demands of that mission to send the first woman and next person of color to the lunar surface by the end of the decade. heralding in a really significant cultural shift in how we view humanity's place in the solar system, because that'll herald the first time that we've had a permanent human presence beyond low Earth orbit, not just in the International Space Station, but out on the moon. And as humanity progresses outwards into the solar system, what does that mean for us here on Earth? How do we continue to use the technologies that we're developing for spaceflight for downstream benefits here on Earth, improvements in the efficiency of solar panels, water use in processing and manufacturing? One of the technologies that my research group is doing at Swinburne is trying to figure out how we can extract useful resources like metal and oxygen from the lunar regolith. And that's exactly what the NASA payload will be doing or demonstrating as part of this Foundation Services rover from the Australian Space Agency. The rover's job is to go out onto the surface, dig up some regolith, deliver it back to that NASA payload, where the payload will extract oxygen. And this will be the first transaction of space resources we've ever had before. And Australia acting as a really key moment in history, being the provider of those resources. And of course, Australia's national heritage being one of the world leaders in resource acquisition, remote operation, and robotics. There are so many mines across Australia operated underground, which resemble a lot of the environmental harsh conditions that operating a rover on the moon will have to face. Really tricky temperature shifts, issues with communications, really harsh dark illumination or bright illumination environments, and extremely harsh for humans to survive there. Just as a reminder, so NASA's vision for the next decade as part of the Artemis missions are to send humans back to the lunar surface, but this time to stay. And why are we going to the moon? Well, because this is part of the broader Moon to Mars program, where we're seeking to put humans out onto the surface of Mars in the not so distant future. And all the students out here today are part of that Artemis generation. As I was saying before, they are going to be witnessing the next step, just like Neil Armstrong did back in the late 1960s, that first step of humans onto the lunar surface. Well, we are returning, and this time to stay, with a permanent human presence out on the lunar surface. The difficulties associated with that, because you can't simply ferry them resources all the time. It is expensive. It is very risky. If those resupply missions fail for whatever reason, does that mean the astronauts are left there stranded? How do we make sure that we're bringing them back on a return duty cycle? And that needs to happen, because humans in space, even on partially or slightly lower gravitational environments like Mars, but especially on the moon, and even more so in deep space, how does space radiation, how do the effects of lower gravity impact the human body? This is a really critical research area. So if you are tuning in back home and you thought, how do I get involved with this robotics challenge? I'm not an engineer. Well, if you're interested in human biology, if you're interested in psychology, how humans interact in group settings, how they interact in stressful environments. What about enclosed environment where you can't go out and have a walk, you can't go out and see the trees and the animals because it's a long journey to the moon and Mars? So all these different disciplines need to come together to make sure that as we venture out into the solar system, we're doing so as humanity. We need everyone, including you. So again, the focus out here at the Australian Rover Challenge is rovers. And speaking of rovers, the RMIT team are currently at that start gate. Go for it. 10:27 on the clock. 12 minutes into their start task time for the Boeing mapping and autonomous task. And thank you for Boeing for their return sponsorship of the competition. It's great to see the industry really getting behind this competition and making sure that those pipelines between industry and students are secure. because we are training the future workforce out here with these hands-on skills, these really essential skills of interpersonal teamwork, perseverance, problem solving, and then of course the pure technical skills of PCB design, manufacturing, carbon layout, CAD design, testing, integration, operations. Again, the task time is 10:28. Each task is 40 minutes. And again, 13 minutes past that 10:15 start task time for RMIT Rover team. And it's really great to see them coming back here with almost a complete redesign of their Rover. And you can see just over to the start gate of the mapping and autonomous task to the left of that lander, this huge rocker bogie carbon fiber linkage suspension system, those 3D printed wheels. Now, rocker bogie just means that front initial rocker, those two wheels to the left and middle, and that bogie sticking out to the back. Now, this is the same suspension system used by NASA Curiosity and Perseverance rovers out on the lunar surface. That 6-wheel configuration, which we've seen a lot of teams opting for, provides excellent traction and ability to traverse over tricky terrain by distributing those forces across the surface, making sure the rover doesn't tip over in case it hits a rock. And that carbon fiber allows that really rigid structure to be able to distribute those forces but maintain its light weight, which is really important for two reasons. One, to make sure they stay below that weight limit for the competition here, but taking those lessons forward in terms of material selection and optimizing the design of their rovers to make sure that when they design systems for space, always minimizing that mass, because mass is money. And of course, as we've seen over the last decade, that cost for sending each kilogram into space, low Earth orbit, is the most expensive to try and get out of Earth's gravitational well. Earth with 1g, one gravitational constant, always pulling everything down. So you need to expend even more fuel, even more energy and propulsion to lift mass out of that gravitational well into low Earth orbit. And the cost of that is dropping exponentially each and every year with reusable rockets, with more frequent, larger payload carrying capacity. And just a food for thought in terms of every time you add mass, you need more fuel, more energy to ship up that mass. But fuel has mass, so you need even more fuel to send up that mass. So if you're home and you're interested in solving these problems, I recommend becoming a propulsion engineer, a rocket engineer, because it really isn't rocket science. And again, that red and black coloring system of the rover to the front of that rover, you can see those two eye-looking cameras providing depth and stereo perception. And again, these are cameras at optical distances, allowing the rover to figure out where it is, how far things are in front of it. And what does stereo perception mean? Well, you're looking out of a pair of stereo cameras right now. Your eyes, stereo, if you close one eye, it's really tricky to get depth. But if you have both of them, you have two different reference frames separated by a slight distance, which allows you to try and navigate, and your brain does all that processing really, really rapidly. So that stereo perception allows you to understand how far away things are, providing that depth, and we can do just the same thing with cameras. You get two cameras, separate them out by a certain distance, and then you can compare the images coming in, do some processing, just like our brain, and figure out depth. And why do you need depth? Well, as your rover's traversing out onto the surface, to make sure you don't collide into any obstacles and cause damage to itself or the infrastructure, understanding how far away things are is really important for two reasons. First one, every time the team collides with something out here on the pitch, that's a 10% penalty to all their points for this task. And two, if you collide with something on the lunar surface and cause some damage, well, you're in for a bad time because there's no RSCV to come and help you.
Although I haven't really studied it. I know it does. I always done the job, never really looked at it. Yeah, it really does. Yeah. Let's prove it. Yeah. Let's prove it.
So I'm down here in the pits next to the RMIT Rover. So I'm joined by...
Chavishka, I'm the team lead for the team.
Awesome, Chavishka. And so the Rover hasn't been moving for a while, and I've heard that there's some some communications issues with between the NVIDIA Jetson and the Latte Panda. First of all, can you tell us what those words mean?
Well, the Latte Panda is the rover's primary computer. It's connected directly with our radios and via a network switch, and that's what we send all commands to. It communicates to the rest of the motors and any other bits of the rover over CAN bus, so it's like the main communications hub of the rover. All of our autonomy and image processing runs on the Jetson. So it takes inputs from the stereo vision and depth cameras mounted at the front of the rover, processes that, and gives us an output command of like go forwards or go backwards. Currently, communications are working okay. The issue is to do with the inputs from the two front cameras, which aren't giving us exactly what we're after. I can't give you anything more specific than that.
Yes, of course. And the reason why is because the base station team are still currently operating the rover. So any information that we relay out here on these huge PA speakers, they can hear us. But I was interested, I've seen a lot of teams converging on that matter of choosing the NVIDIA Jetson. Do you want to discuss a little bit more on why everyone is choosing the NVIDIA Jetson and what functionality it provides?
Yeah, so when you want to do image processing, you need to pick something with a pretty hefty GPU. It also needs to be a single board computer because anything bigger than that is probably not feasible on a rover like this. So in terms of consumer level hardware, the Jetson is probably one of the easiest choices to make. It's got the right amount of processing power for exactly what we're trying to do. And that's helped by the fact that we're offloading all comms stuff to the Latte Panda. So its sole purpose right now is just processing our inputs for autonomy.
And it's fantastic to see the team performing so well over the previous 3 days of the task. in terms of that rover redesign, it's completely different to what you brought to us last year. And it's great to see the team really working hard in that design, development, and testing cycle. So we're going to discuss a little bit more on why you chose such a large wheelbase in terms of the huge dimensions of those linkages between the rocker bogie system, and some of the decisions you made on how you managed to shrink down that chassis so much. So you can see up on the screen there that huge clearance between the wheelbase and the bottom of the chassis. How did you manage to really streamline and optimize things and make it so different from last year?
Yeah, so it's a completely new redesign. None of the parts are the same, so it's a fresh Rover. We're still relying on the rocker bogie system. It worked very well for us last time, and the suspension is able to manage almost all obstacles we can throw at it. We have quite a high clearance, so we don't really need to care about obstacles too much, to the point where we can, if you saw us yesterday, we were just driving over most of the obstacles we came across. And that really just helps us with just optimizing traversal time to wherever we need to go, really.
Yeah, and you've been part of the RMIT team for quite a while now.
Yeah, so I joined in my first year. I am now in my fourth, so quite a while.
And it's in terms of looking forward to graduating soon. In terms of the some of the demonstrations we saw from ELO 2 yesterday, and also the ROSE Consortia, it's great to see that those opportunities for technologists like yourself with specialty in rover design and development, it's great to see that ecosystem of opportunities really growing. In terms of the team size, how big is the team currently now?
So this time last year, we had 14 people, which wasn't very big. Now we have just over 40 active members. And by the looks of things, I think we're going to grow a bit more as well. So we've expanded a fair amount.
And that's great to see. So one of the key things that we really love to see at the Australian Rover Challenge each and every year is the growth of new teams as we expand across Australia and the world, but also the growth of existing teams to reach that increase in personnel and increase in knowledge base and expansion of just how many people this competition does reach. And really, these are the skills that a lot of employees are really looking for, not only those technical skills of design, development, and interaction, but the soft skills of how do you work amongst a large team like that? How do you manage a team growing from 14 to 40 to 100 people? These are the skills that employers really care about. So it's great to see the teams really demonstrating and flexing those skills throughout this 4-day competition and building up that skill base over several years. So Trivishka, thank you very much.
Tug of war, how are you attaching the props?
I think we'll take one of the panels.
Sorry, can I just confirm that we're ready to go?
During autonomous mode, you can also stop the rover yourself from the base station. As long as the rover stops within the rover remains stationary. So wait, does it all happen on smartphone, blue, red, green, white? I think our low rover is fitting the challenge. There's also no tug of war guard. Demonstrating it here.
So we do have movement. So the Rover has left the start gate. By moving those wheels, it has just shifted its first little baby steps out of that starting gate. And you can see in the back that lander, the descent ramp, which we've been using across some of the tasks spread across the Australian Rover Challenge over the last 3 to 4 days. All these props designed and built by a theatre company, hence giving us that huge sense of scale and realism, making this lunar surface really feel like we are all out here on the moon. And again, 10:43, just under 30 minutes into their time, just over 10 minutes left on the clock for RMIT's attempt at the Boeing mapping and autonomous task. There you go, 11 minutes. Plenty of time to get a few points. And again, as Travishka was mentioning just earlier, some issues associated with communicating between those key pieces of infrastructure inside the rover, those communication protocols to the NVIDIA Jetson and the Latte Panda. Trying to iron out all those kinks is one of the next steps that a lot of teams really need to try and secure down, make sure that redundancy and reliability are the cornerstone of their rovers coming back to next year's Rover Challenge 2025.
Let's make half of our budget on gold plating. It'll be funny.
So just confirming the view right now of the rover, you can see those rear and middle wheels. It has not successfully left the start gate yet. All wheels, just like the previous tasks of descending down the ramp, all wheels with full contact of that wheelbase must leave the start gate in order to be awarded those initial 5 points. The time, local time here in Roseworthy, 10:47 a.m. Their start time was 10:15, and the rover does make its steps out onto the surface. And if it does collide with any of the props or rocks, that is a 10-point penalty of a collision. And the Rover really making good pace here. 6 minutes left on the clock. Every single block it can identify to us and localize an XY coordinate frame. Those are some really needed points.
Yeah, probably. That would make sense. Yeah.
5.5 minutes left on the clock, and the Rover just creating a crescent way around that bottom left processing plant. And the Rover is currently being manually operated, having left the start gate in a non-autonomous fashion. So again, the base station team operating the Rover and trying to map out the surface and figure out the coordinates of those blocks out on the surface, including the placards that we've stuck onto some various sticks and props. And these are all trying to get the Rover to help us understand its ability to figure out where it is in a two-dimensional plane, as well as three-dimensional in terms of describing the heights of those placards and telling us what content is on those images. Now, all of this is trying to demonstrate, at the end of the day, that the Rover can, one, figure out and map itself, and either do that non-autonomously or fully autonomously, navigate across the field, avoid obstacles, figure out the location in the X and Y frame of those blocks and placards, tell us the information of the placards, and ultimately get full points for this mapping and autonomous tasks. One of the most difficult tasks in terms of the complexity of getting all those systems, those fundamental systems, including mobility, suspension, wheels, drivetrain, operations, communications, all working seamlessly so that that mapping feature does work as intended.
It was yes, that one's too long. So we wanted a shorter one. And I found that. No, the bolt was too small. It's super good at that quality. Put it on top. Screw it on so it won't fall off. It might have been that one because I kept going through the fuck, it was too long. Yeah, I found one that was slightly shorter. So it might have actually been that one. So that might have actually saved the day because I was looking for 8 on the back. Yeah, so then when I first did it, I put the nut in there. And I took it immediately dried. And then I realized I had the wrong bolt. So I had to actually that
It works in specs. Look at this.
And with just under 20 seconds left on the clock, you can see the Rover there out back to the nearby the original starting gate of the lunar lander. And as the task time for the RMIT Rover team comes to an end, let us get a huge round of applause for their phenomenal effort, being able to overcome all those issues associated with communications. And great to see them really giving this task a red hot crack. And as a reminder, coming up next, we've got the Adelaide Rover team starting at 11. Uni-Melbourne Rover team at 11:45, QUT at 1 o'clock, UQ Space at 1:45. Project Scorpio, the current #1 lead at a very comfortable amount of points. From Poland, 2:30 o'clock. And lastly, Monash Nova Rover from Monash University, the reigning champs for the previous 3 years, 3:15. And of course, we've got the award ceremony at 4:30 to 5 o'clock, followed by some fun and games out here on the lunar surface as we really get the teams, no holes barred, traverse across the surface, do some tug of war, king of the hill. Really, this is what it's all about. The tasks and the points are fun, but everyone comes for the tug of war where the real winners and champions of the Rover Challenge are crowned, where we get to see the full power of these Rovers unhinged. And of course, that will conclude this year's Australian Rover Challenge. And thank you very much for those of you who've been live streaming, watching us here on this marathon Herculean effort across 4 days. And as a reminder, 4 days, 4 tasks, 400 points split across 100-point individual tasks. Originally, we had Thursday, the Australian Space Agency post-landing task. Friday was the ELO 2 excavation and construction task. Saturday was the iSpace Space Resources task, and today, on this beautiful sunny Sunday out here in Roseworthy, we've got the Boeing Mapping and Autonomous task. And again, a huge thank you to the additional sponsors making this challenge possible, including Caterpillar, CSIRO, SASIC, Mini Mammoth Games. All of you really coming together and making sure that these students have full access to industry opportunities, engagement, discussion, advice, and get to see what the real industry is like. And I'm very much looking forward to how much growth we've experienced as a competition in only 4 years. So really looking forward to the next 4 years of growth, how big we go, how big we can get, the complexity of the tasks, and if we can really showcase to the industry some really unique and important R&D opportunities.
This is where it started, and where you start. This is where you become tomorrow's
CyberX.
This is where it started.
Yeah.
We'll do what the same plan that we had yesterday.
So it's more like 41 with that lease. No, actually, no, it's half of it's on there. So that's oh, okay. 4 kilograms of ammunition.
The same plan, right? I just
One person.
Yeah.
One person. I can do the close up because that's what you're doing, right?
Yeah.
So I can sit in the front and do the close ups again.
Yeah, that's true. There's a lot of
the
lead.
side, and then another person filming your team's reactions. I felt like that worked.
This is where it started and where you start. This is where you become tomorrow's
cyber expert,
Physiotherapist.
CEO, or musician.
This is where your time begins. Make history at the University of Adelaide.
And welcome back. The local time is 11:02. The official start time for the Adelaide Rover team, which you can see up on the screen right now, is 11 o'clock. And again, that awesome rocker-bogie system, individual pivot steering with that L aluminium linkage connected to those 3D printed wheels, flexible black 3D printed rims, providing a little bit of deformation there. And you can see that inner red 3D printed hub, the large LED spinning at the top, that orange LED telling us that the Rover is currently powered, and a large autonomous module mounted to the front. Some additional cameras providing additional awareness and perception of the obstacles potentially in front of it.
phonetic alphabet.
So the field team right now performing some last minute changes and modifications to that rover, that autonomous payload that they've mounted to the front. And again, as we get to see these rovers evolve every 24 hours, some great innovation, some late nights, lots of coffee. The view up on the screen right now, you can see the base station set up with their monitors that they've brought, currently trying to connect and establish that secure connection from their base station antenna, providing them with that live stream to the rover. And as we saw just previously with the RMIT, just some of the complications that can arise between the rover's internal subsystems, make sure the communications does remain stable and strong, so that mapping an autonomous task can begin. And again, as a reminder for those wondering what exactly the rovers need to do, well, 5 points are available for leaving the start gate autonomously. The start gate being that graded area to the bottom and front of the lander. And up on the screen right now, you can see the available points, the point breakdown. Again, 5 points for leaving that start gate autonomously, 30 points for autonomous landmark navigation. Now, out spread across the field, you can see, well, out here, spectators, we can see attached to some of the props and some of the wooden stakes, individual placards with information on them. Now, the team needs to convey that information to us, the judges, to figure out what content is on those placards and where those placards are in reference to the map that the team needs to give us. And then after that, 40 points of exploratory mapping. Now, the team can do this either autonomously or non-autonomously, and they get points depending on which mode they're in, as well as how accurate they are in determining the location of colored blocks across the surface. Now, you can see these colored wooden blocks spread out across the surface. And then a question would be, well, how do we know where all these things are in a high fidelity environment? And thanks to Cyro's magnificent and world-class capabilities in mapping using LiDAR, just previously on, as the post-landing and excavation tasks were concluding, some personnel from Cyro mapped out every square millimeter of the surface in incredible detail, including color. And from this map, we can calculate the coordinates of where we've put these objects in extreme detail. And this is the reference plane of how we score and judge each of the team.
Just come on in. We won't close until you're in there.
Well, you would say Ray. So if you and Ray, and that would be the most ironic thing ever. Originally, what would have been? Let's go on a software versus on a mechanical system.
And as we get a closer look of that rover, you can see mounted to the top of this 3D printed arrow panel, one of their key cameras, and just to the bottom of that, mounted to the very front, an additional camera. Now, these cameras are providing perception and awareness to that rover. And just to the left of those, mounted on top, you can see that large spinning orange LED, critical for telling us, the judges and the field team, that the rover is powered, it is operational, and to remain aware and safe. And just to the left of that, that big red button that every kid wants to press. But that is the emergency stop button, ceasing all power to the rover's internals. And we use this to make sure that if anything goes wrong, we can end the rover safely and also prevent any electrical fires. And just beneath that, in the machined folded sheet metal, that newly designed chassis containing all of the rover's electronics, and then mounted to that, the rocker bogie suspension system using these aluminium extrusions, conveying or surrounded by those electrical wires which are connecting the rover's internals, the processing unit, sometimes a Jetson, sometimes, as RMIT was mentioning, a Latte Panda or any other commercial off-the-shelf component, which they use for processing and conveying the signals sent from the base station team to the rover, and then transmitted down those cables to the motors which drive the wheels. And University of Adelaide opting for this unique individual pivot steering, so you can see the individual motors sticking out from the top, to providing a rotational base, spinning that wheel on a dime, and then that right-hand bracket, that curved C bracket, connecting to the inner wheel, providing rotational movement of the wheel. So you can imagine that each of these wheels can pivot on a dime, providing full 360-degree motion, and then this allows the rover itself to pivot and also potentially move laterally, as Monash University were demonstrating previously across all their tasks. This is really complex. Now, implementing these solutions into a rover takes several years, lots of R&D. But is the risk of that R&D development period worth it? Does it pay off? Because again, with all this complexity, this contributes to lots of additional variables that the rover needs to figure out during this mapping and autonomous phase. And there you can see right now those wheels pivoting on a dime. Quick demonstration of the University of Adelaide's team efforts towards getting that drivetrain working as intended. And across the previous tasks, we did see those wheels snapping to attention with every movement, so that pre-programmed nature. And you can see the deformation of that rocker bogie system as the weight is offloaded. So just giving you an insight of how the weight is distributed through that suspension. And the team right now carrying the rover out onto the field. View of the base station. And hello, Mum. Thank you for tuning in. You are watching the Adelaide Rover team. The time is 11:11. Task start time wasn't 11 o'clock. 40 minutes of task time, meaning just under 30 minutes available. And yes, hello, Mum and Dad. Hello to all the family and friends tuning in to this beautiful sunny day at the Australian Rover Challenge, our 4th year out here in beautiful South Australia, and welcome to Roseworthy. And boy, what a magnificent day it is. It is extremely sunny, not too hot though, not a cloud in the sky, and beautiful weather out here on the pitch, simulating sort of what it might be on the lunar surface, where there is just pure unfiltered sun slamming to that lunar surface with no atmosphere, meaning that the temperatures can exceed 100 degrees Celsius, and the moment the sun drops, nowhere for that heat to stay except in the lunar regolith, which is extremely insulating, meaning the temperature can drop at night to minus several hundred degrees. Now, what does that mean for the temperature environment? What does that mean for rovers operating in a high vacuum environment with no atmosphere or magnetic field? How does radiation impact your electronics? Every time there's the potential for a point failure interfering with your code, how does your electronics and your code base remain resistant to radiation damage? Making sure that every system works even under the extreme environment of transiting through space to extraterrestrial planets and moons like our own moon, but also Mars. And why do I say all this? Well, NASA, as well as several space agencies around the world, as part of the International Space Exploration Coordination Group, ISECG, they have laid out a plan to return to the moon, this time to stay, but also venture onwards to Mars. And this is part of NASA's Moon to Mars program, where the foundation for supporting humans on the surface of Mars must first be demonstrated, validated on the surface of the moon. And this is why we are venturing back to the moon as part of NASA's Artemis program. Artemis, of course, being the sister to Apollo, and Apollo being the exploration program in the late 1960s, early 70s, as we sent humans to the moon for the first time to conduct some really needed exploration surface missions across the lunar surface to figure out and address some really fundamental questions like how did the moon form? How did the Earth form? How have they evolved over billions of years of geological time? How does the solar system evolve with time? Because we can also look at how the surface of the moon has changed over time to figure out how the bombardment history has changed. So we've learned some really important things like early in the solar system, we had this late heavy bombardment period where all the debris, all the leftover material from the planets forming rained down on all the planet's surfaces. And we can actually get a history of time by analyzing those craters, that surface morphology on the moon, and create and work backwards this history, this timeline of the surface evolution of the moon, and also learn about how the oceans on Earth formed. So addressing some really unique and fundamental questions that actually do have a lot of downstream benefits for us here on Earth. So investing in space, in having an inquisitive mind and asking these questions, really important for addressing some fundamental questions here on Earth, like climate change. So did you know that solar panels were originally invented to power satellites in space? So again, another clear demonstration of space technology having really significant downstream benefits for us here on Earth, including lasers, X-ray, micro, CT scanning machines. All these systems really critical for human health, human safety, GPS. I bet if you drove somewhere today, did you use Google Maps? Well, that wouldn't be possible without this huge global satellite network out there in geostationary orbit, providing us with that well-needed information to make sure that you can get from A to B. And really critical for also enabling the global flight patterns of aeroplanes and key shipping lanes around the world, because you can't get information everywhere using a radio antenna. You need satellites. You need high fidelity, high accuracy satellites, providing a lot of bandwidth to let the global shipping lanes around the world stay in connection and also have room to scale and grow. Now, all these systems, why do I mention them? Because as we venture out to the moon and Mars, we are establishing an economy. So you would have seen recently that several private companies, as part of NASA's CLIPS program, the Commercial Lunar Payload Services, NASA is now shifting towards a private sector approach, allowing private sectors to bid to send infrastructure and payloads to the lunar surface for a price. And this is really demonstrating and opening up a pathway for a new industry to be born, a space industry, opening up so many new jobs, so many new areas of technical expertise, so many new areas of requirement. How do you address space health? How do you address infrastructure in space? How do you refuel spacecraft? How do you deal with low gravitational environments and fluid flow? All these really critical things that need to be addressed. And boy, do I love a challenge. And speaking of a challenge, the start time is 11 o'clock. The local time is 11:16. Adelaide Rover team still trying to troubleshoot, make sure that their system is functional. 23 minutes left on the clock, a total time of 40 minutes left. So plenty of time, more than half the time available for them to lift that start gate autonomously. And again, you can see up on the screen right now the picture-in-picture of the rover in its start gate to the front of the lander. Those 3D printed wheels. Lots of teams opting for 3D printed wheels, most likely due to the rapid prototyping and how cheap it is, and the ability to create an entire wheel in less than a few hours, less than a few days in some circumstances, depending on the complexity of the wheel, what material you're using, what layer height, what's the internal geometry, what's the infill pattern, all these things, giving the teams full control over the shape, design, the mass, the load distribution of their system. However, 3D printed materials in space, how does the radiation environment affect 3D printed materials? It's not great. So again, this is another huge area of research in material science. And it looks like the rover is taking its first steps out onto the surface. Now again, this may be in an autonomous or a non-autonomous fashion. In order to get those points, it needs to be leaving the start gate autonomously. However, they can transition to the exploratory mapping portion of the task 40 points available for navigating across the surface in a non-autonomous fashion, and then localizing to us, the judges, the location of those blocks in an XY coordinate frame, which we judge against a map which we've collected using LiDAR, brought to us, thankfully, from Australia's National Science and Technology Organisation, CSIRO. And thank you to them for also helping us with judging today's competition. So out on the field right now, you can see the University of Adelaide Rover in that pivot steering orientation, each of those wheels forming an arc around the rover, allowing it to pivot on a dime, offering up a huge amount of flexibility in terms of how it maneuvers across the surface. So this is in contrast to a lot of teams which use skid steering, which consists usually of a four-wheel suspension where you pivot each of the wheels, not pivoting as efficiently. There's lots of slip and traction associated with that. So again, this is one of the challenges that may be overcome by using this complex system. But again, it's that decision of risk versus reward. How much complexity do you need? How much complexity is required? And again, just time is 11:23, just under half time left for the task, for the Boeing Mapping and Autonomous task. And again, quick shout out to all the sponsors who've made this Australian Rover Challenge successful to the extent that it has been a huge 35 by 30 meter analog facility. And speaking of this facility, I'm joined by John Coulton, the head of the Andy Thomas Space Resources Centre, who've made this incredible facility possible, enabling the Australian Rover Challenge. And I was interested, John, in terms of the future applications and beyond the competition, what did you have in mind for this beautiful analog facility?
Thanks, Dan. Yeah, so the Andy Thomas Centre for Space Resources at the University of Adelaide is our mission statement is enabling long-term human presence in deep space. So we have a focus on humans, but the humans are going to go into space with their robotic companions that are better suited for harsh, dangerous sorts of tasks that are going to be required to support those humans. So we really do need to, while we explore the psychology and health and medicine required to support those humans, we need to also explore what we can do to support our robotic companions. So we do have some facilities at our campus in the CBD here in Adelaide that allow us to do small-scale trials and put lots of different things into lunar and Martian simulated environments. But we needed a place where we can expand that into full field-scale dimensions. Yep. So we have a 4,000 square meter facility here, complete with a mission control and a robotic workshop to support all of those experiments, student and industry experiments that get that are getting closer and higher up the TRL scale as they mature towards actual implementation in the real world. We need a place to test them.
So that smaller, high fidelity facility you were mentioning, the Exteriors Lab back at the main campus. So one of the things I did see back when I visited a little bit earlier last year for the previous Rover Challenge was a high fidelity lunar simulant, as well as some cameras providing some really well needed positional orientation so you know where your rover is out in the field to help you backpedal out in terms of the mapping and autonomous task here today, collecting data from the rover and then comparing that against the system provided by that facility.
Yeah, so on North Terrace, we have an OptiTrack system in our larger sand pit, and then also in a miniature NASA SwampWorks sort of facility, which is 10 tons of lunar highlands simulant. And we can measure everything that's happening inside those spaces at the sub-millimeter level. Out here in this facility, we have high precision GPS capability, so we can't quite get to the millimeter level, but we're in the hundreds of millimeters in terms of accuracy for each piece of the rover, which of course is extremely important when you're doing a task such as this.
So one of the other key benefits of this facility is not only research for the academics and the students, but also the collaboration with industry partners. Can you speak a little bit to, so we saw ELO2 demonstrate their rover here and being remotely controlled from America. Are there any other future plans or the key purposes or applications of this facility in terms of international partners interested in coming over? Is it mostly for lunar robotics or localization? Is it for collecting data? What is your vision in terms of the scope of utility that this facility provides?
Yeah, so of course, like you, we're space crazy sort of people. So when we look at this, we think of space utilization and space work. We do have a number of industry partners, 3 that have already been doing or conducting research on this field since we opened it on Wednesday. So that's a fantastic data point with regard to industry's need for facilities like this. But the reason the doors on the facility behind us are so big is because we also have automated agricultural tractors that would do agricultural work as well. So this is a multi-purpose facility. Space is our flagship domain, but we're looking at any sort of application with regard to robotics, including astronaut autonomy teaming. So we will have folks out here working with the robotics side by side as we advance those kinds of technologies as well.
And I can't help but ask, John, but if you were your younger self and you had the opportunity to compete at the Rover Challenge, I was interested in what subsystem would you love to work on, or what aspect of the team would you love to try and get involved with?
I'm a civil engineer, so I have a preference for those kinds of tasks myself, and also the mining is pretty cool. Yeah.
Well, fantastic. Thank you very much, John. And thank you for enabling this and allowing us to provide this sensational platform and opportunity for these students around Australia and around the world. And I tuned back to the Adelaide Rover out on the field, and it's making excellent progress, making its journey over towards the back of the hill there, towards the comms tower. And again, the base station team up on the screen right now, showcasing the live camera feed. Hello there, you can hear me, of course you can. Showing the team operating the rover as it traverses itself, trying to localize and map that surface, tell us where those blocks are, the color of the blocks, and getting those points. Of course, this is non-autonomous. Additional extra points are awarded if the rover achieves these tasks in an autonomous manner. And you can see the sense of the scale of the pitch out here. And just to give you a sense of the complexities associated with mapping, the scale here means that every single error accumulates really, really rapidly. So that error margin of where you think the blocks are begins to accumulate with every step you take, as the wheels really need to make sure that they're keeping traction on that surface, that loose terrain, that loose lunar soil, really low bulk density, high porosity, which means that there's a lot of slip. So if you are using wheel odometry, if you are trying to localize yourself using the data collected from mechanical systems, it makes that really difficult to remain accurate at a single instant, but also accurate across time. Now, a lot of teams opting for the use of cameras or stereo cameras for depth perception, which enables obstacle avoidance. And again, why are teams doing this? Well, they care about avoiding the 10% point penalty for a collision, but the application of that technology is to avoid rovers damaging infrastructure or themselves when deployed to the lunar surface.
Are you serious? Yeah. Well, twist that one. So the front will face so front green, yeah? No, the front will go this way. Okay, so red. No, it's here. Yeah. Like no, this is X Y. I'm doing this. Yeah, X and Y. And you go like that, right? Well, not going X, going middle part. Oh, middle part. We want avoid that rock. We want to avoid the rock. So we just go 5 seconds. All the 5 minutes or 5 minutes. It's drawing by itself for 5 minutes. And you have no control of it. Right? So we're just gonna.
So as the rover takes its last steps in the remaining 10 minutes of this Boeing Map and Autonomous task, speaking of Boeing, I'm joined here by Glenn. Do you want to give us a brief introduction of who you are and your role with Boeing?
Yeah, thanks very much, Dan. Yeah, hey, I'm Glenn Gallagher. I'm the operations manager here for Boeing and Boeing Defence Australia in South Australia, and I guess my main role is supporting Boeing's interests in South Australia. Look after about 150 people in the office in Adelaide, and we've got about 160 people out at the Air Force Base that we support that doing Boeing products.
Fantastic. And I really want to thank you and the team at Boeing for your continued support of the Australian Rover Challenge, of course, helping us last year with the mapping and autonomous task. And it's great to see that as a judge, you're interviewing, getting hands-on experience with the students. And I was interested in terms of not only supporting the Rover Challenge over the last 2 years, I'm interested in terms of Boeing's perspective of their role in the Australian and global space industry as their transition into the NASA Artemis missions going forward and seeking to put rovers like this on the lunar surface and humans. So I was interested in terms of what you think Boeing's role in that next 5 to 10 year period would be, and also your role in terms of Boeing moving forward with that mission.
Yeah. Thanks, Dan. Yeah, so Boeing partnered with NASA for the Artemis program. For those who didn't know about Artemis, that's Apollo's twin sister. And so the big mission there is basically exploring deep space. Now, as all the people here and people watching online, that is not a small task, nor is it an easy, quick one to do. So it's longevity, 5, 10, 15 years, putting humans into deep space flight. So with the Space Launch System for the Artemis system, Boeing's doing basically the core launch modules for Artemis 2, 3, 4 and 5. And what they will eventually do with NASA will be putting the first woman around the moon, on the moon, and first person of colour also on the moon, which is one of the big parts that we're partnering there for. Challenges faced is the physiological impact of humans in deep space for long periods of time. That can't be underestimated. So the human factors component is where Boeing sees probably the key factors. We're pretty good at the aerospace engineering's part, but the human factor is the untold question that we would need to work with for the people taking part.
So yes, making sure those crewed modules are human grade is such a huge issue in terms of the development of those technologies. So there's such a huge difference or dichotomy between qualifying a spacecraft for purely robotics and then making sure it's capable for supporting humans in that long-term duration, that transit, and also during egress or launch initially. So it's great to see Boeing really pioneering and making sure those crewed modules are ready for Artemis to make sure that we can hit those timeline and that broad mission of returning to the moon, and as you say, this time to stay. And I was really curious in terms of beyond that whole mission scope of pioneering into space with all these private companies coming together around the world, for students out here at the competition today, what are some of the challenges that you're seeing they've faced or overcome over the last 4 days that you yourself with the team have thought that, hey, we're running into the same issues, or these challenges are actually real world issues that companies are facing right now?
Yeah. Absolutely, thanks. And as you know, the austere, sparse sanctity of space is hard. So bandwidth and resources are one of the key challenges. It's great with all these excellent cameras and LiDAR generating so much imagery data, but that's a storage resource cost as a bandwidth cost. Okay, that can't be understated or underestimated. That's one of the big challenges. The other one is image recognition, which is excellent because the way we do images is the database set you're going to need to manage is going to almost be endless for what we're trying to do and achieve on a lunar sense. The other parts that are probably the challenge is exactly here today, your X, Y, Z coordinates for when you don't actually, maybe your origin wasn't what you thought it was. That's a key part that people need to overcome.
Yeah, so really trying to make sure that mapping and localization is addressed. And I've been mentioning it a lot, the lunar surface currently has no key infrastructure. So that's one of the things that the Lunar Outpost company over in America are trying to address with their upcoming mission, partnering with Nokia to try and deploy 4G. So let's see if we can try and develop these key infrastructure and communication protocols, that internet, that IoT that is required to make sure these missions remain in connection with each other. And speaking of bandwidth, I'm aware that NASA's Lunabotics, which is their version of a rover competition demonstrating excavation and deposition, they actually measure the amount of bandwidth used by the rovers during their competition. So the reduction in bandwidth required as you compete, the reduction in mass, the reduction in power consumed, these are all variables that contribute towards an increase in your score. So it's one thing to see that at NASA really being pushed through the teams so that they can learn about the importance of minimizing mass, power, bandwidth requirements, size, complexity. And of course, I've really got to ask, as I did John, with all these students out here today, so when I was doing undergrad, so a lot of the opportunities that exist today for Australian students and around the world didn't exist. And I was curious in terms of, if you were your younger self and you had the opportunity to join a team, what subsystem would you work on? What aspect of the rover? What would you love to get your hands on?
Thanks, Dan. I'm going to echo that comment of what was around, and I'm not going to say something about a slide rule or things like that I maybe used when I was doing some engineering studies. However, I'm going to say machine learning and coding. Play to your strengths. I'm pretty good at the aerospace and systems end stuff, but the coding and the machine learning and what's available now, it really excites me. And I guess I'm just in the short space of judging today. I've learned so much from looking through at what the teams are doing, and that's really inspired me. So I'm very grateful. So yes, that would be a big part for me to come back and get my hands dirty on the codes.
Well, fantastic. Thank you so much, Glenn, for getting down here and helping as a judge, but also supporting the challenge and making it able to elevate to the standard and scale and size that we have out here today. So thank you very much. And as we tune back in, just over 2 minutes left on the clock for Adelaide, demonstrating again that pivot steering right next to that blue block. Every point here counts. If they can tell us, the judges, the location of those blocks in two-dimensional space, telling us that map that they've been collecting over the last 40 minutes. Again, every point here counts. And if we look back to the leaderboard, as we reshuffled following the calculation of space resources points from yesterday, the leaderboard has mixed up a fair bit. And just over 1.5 minutes left, and you can see the Rover's suspension system really coming in handy here, that traction, the ability of the team to really overcome a lot of the issues they've encountered in the past over previous years. And again, that side-on profile, the scatter of the wheels, making light work, and you can see the traction, the tread, the imprint of the Rover as it traverses across the surface. And an interesting note, the Apollo program from America and the Lunar program from Russia, or formerly the Soviet Union, one of the key things that they did to figure out the mechanical properties of the lunar regolith is take pictures of the treads of the rovers as they traversed across the lunar surface, but also the boot imprints of astronauts. And you can learn a lot just by looking at the shape, the depth, and the morphology of these imprints on the surface, and it tells you a lot about the geotechnical properties of the lunar regolith. So again, just under 1 minute left, base station team rapidly trying to figure out, localize, and they've got 10 minutes after this to process all their data, following which they'll have a 10-minute presentation and interview with Glenn from Boeing, as well as our head judge, one of the head judges here, Lucky, who will be questioning the team about how the data they collected is valid, and also the content of maps. And as a reminder, they'll be scored based on the accuracy of where they think, if they've made a map, in terms of the accuracy of the start gate, as well as the location of the blocks on that map. So just as the timer ticks down, I'd like to get a huge round of applause and a congratulations to the University of Adelaide team for demonstrating their capacity to drive across the surface. Fantastic effort. And it's really trying to climb up that hill and showcasing just how tricky it is, steep inclines are. Thank you very much.
Because I thought you were just going to try and full send it, but end up like ramming it.
This is where it started. And where you start. This is where you find a top 100 university. World-class research. And these little guys. This is where you study crashes. And become cancer smashers. This is where you crush it. Cram it. Glam it. And this is where you grow food. For space. This is where your time begins. Make history at the University of Adelaide.
Having like 5 bonus points if you get on top of one of the hill. Potentially. I guess for next year, have it like at any Henry. Those yellow rocks. Just a big block. Thank you.
I mean, next year we're going to see the Rover you guys have to meet. I reckon it'd be cool. Like, why not?
I think it moves fast enough there.
Do you have like
What's the sizing?
all the way up into the
You got like wet and dry. Moon and Earth motors.
So right now we've got University of Melbourne Rover team with the start time of 11:45.
You can have like
Exactly.
will cause some ear damage forever. Wrong way for you. Purpose up. It's fine.
Putting the rubber down now, you can stop trying it.
Oh my god, that's all these conversations on these pianos.
And currently up on the screen, we've got a live view into the University of Melbourne Rover team base station. Time remaining 33 minutes. 9 minutes in, official start time at 11:45. Again, trying to set up that communications from the base station to the rover. Every team so far really struggling, just highlighting how tricky it is to get stable, reliable communications each and every time. So I really want to stress for all those viewing for the first time, hello and welcome. My name is Daniel Ricardo and you are watching the Australian Rover Challenge. There you are. The Australian Rover Challenge out here in sunny Roseworthy. And thank you for tuning in. And for those who have been tuning in for a long time, welcome back. You are currently watching University of Melbourne Rover team's fourth and final attempt of the fourth and final task at the Australian Rover Challenge, and our fourth year being hosted by the University of Adelaide. And again, we are witnessing the Boeing mapping and autonomous task, which involves the rover's ability to leave a start gate autonomously and then navigate across the surface, identifying the location of blocks and placards containing information that the team needs to relay to us, the judges. And the coloured blocks, well, their job is to drive around the surface using the rover you can see up on the screen with that rocker bogie system, the rocker being the two wheels mounted to the front and that bogie being that long wheel sticking out the back. Now, this suspension being used by the NASA, Mars, Curiosity and Perseverance rovers to great success, and a lot of the teams out here at the Australian Rover Challenge innovating and integrating that existing system onto their rover. And again, many rovers using 3D printed wheels, and this one, again, 3D printed black, flexible material, allowing a little bit of deformation, and you can see some of the chevron-shaped structures translating that force from the outer rim to that inner solid or hub. And then that's connected to the motor, which is connected to the aluminium linkage, which is connected to the chassis, which contains all those rover electronics, often containing a NVIDIA Jetson, being the main carrier board, control processing board for many of the rovers, as it is a simple commercial off-the-shelf product offering a lot of the functionality and onboard processing required for the rover, particularly for this mapping and autonomous task, where there's lots of data being collected across lots of different sensors. Many of these sensors often being just a camera or stereo camera, providing a little bit of depth perception, a little bit of perception awareness. And again, the rovers can complete this in an autonomous, fully autonomous, or non-autonomous fashion, autonomous being no hands on the keyboard, rover driving itself around, mapping simultaneously, or the team can drive around themselves and try and localize the coordinates of these blocks out on the lunar surface.
You idiots, this is easy. Albert, hey Sam. Do you have it? Yes. Yeah. Let's go. We have duct tape. Why would you want really good? I guess. Oh, you were ready. You knew what I was doing. You knew that software. Yep, ready. Alright, I'll pause the Sam, you're gonna have to grab your speaker or something. See how they work last year. This is chassis team level. It's too late for that now. It's too late for that. Yeah, it's almost like you're the longest running chassis member. No, wait. No, you. No. Oh, that's rigid. You welded the shit on. No, we're not. So the thing is, the autonomous one is kind of hard to pick up now because it's not actually on the so we're probably going to take the camera off, the pole on. We might just stick it under our computer. We won't have it in front. Unless somehow we're able to
Wait a second.
Yeah, the Thomas. We saw the exact same angle liner that took the hit. Yeah, and honestly, that was the main reason why I bought it. But we can't bring it.
I'm here with a member of the audience. What are you saying?
We used to.
No, that's.
I'll get him when they come past.
I do that sometimes.
Or they'll come past.
I get a free ride. It's a win-win.
Oh, hell yeah. That's so bad. Yeah, but this says so much. The longer you stare, the weirder it gets. It's a picture of you running Thomas.
Oh! Oh, come on.
Every day someone would run up to it and like put it somewhere. And then on the last day, no one can get a hold of it. Heavy space.
One day I rocked up to the site and it was sitting on top of the berm and I was like,
Can't you just go like forward straight to
The next year we came back with
500?
yeah, you massacred its face.
We still have the same tool that massacred the face. Yeah, the same tool.
They're just trying to.
I never take any photos. There's never any. They want to
Oh, I was in the basement. Oh! Like, because I was supposed to, not because I was being a dick. Everything else. I thought it was ours, so I walked away from it. Oh, yeah, because we brought our own. No, good enough. Very good idea.
This is going to be good.
Come over here. Get the short or the long?
Yeah, you need to. Sorry.
Yeah.
I'll just come sit.
Oh no. At some point you can just say it. Yeah. You're trying to map something.
It didn't die. It didn't make it over the hill.
That was cool. Yeah. It was autonomous to about there.
Well, I'm down here on the sidelines of the arena, and I'm joined by a good friend and fellow head judge,
Henry.
So,
Please keep it together.
The start time of the University of Melbourne Rover team. So we're steadily trekking along. Currently no movement, but this is just highlighting some of the complexities of all the rovers, getting all those complex systems in order and navigating. You yourself have some experience leading a team. Do you want to speak a little bit to that and what it was like overcoming those challenges over in America?
Yeah, sure can, Dan. Thank you for the introduction. You may have seen me on the stream yesterday when Dan was busy behind the scenes organising the iSpace Space Resources task. So today I'm in his shoes, running around making sure where all the teams are. But before I was a director of the Rover Challenge, I was the team lead of Monash Rover for about 18 months there and managed to take the team to the University Rover Challenge in Utah in 2019. It's no mean feat, even coming domestically for a competition. You need to pack up all of your tools, your whole rover, transport it, across state lines for most of them, and then reassemble thing and make sure everything works. And I can guarantee you nothing works the first time. That's how important testing can be, and then to make sure you debug all your issues before you get out here. And like you said, the systems are just so complex. And mapping on autonomous is also just really difficult because you need a really, really solid foundation before you can even start attempting to move autonomously. You need all of your electrical, mechanical, software bugs relating to your movement all sorted before you can even begin to think about how it's going to, map the environment and navigate around it autonomously.
So it's really that bottom-up approach and making sure that mobility system is rock solid. And again, so just to reiterate, so this is the Boeing Mapping and Autonomous task following before that, we had the iSpace Space Resources task, the excavation construction task brought to us by ELO 2, and on the first day we had the Australian Space Agency post-landing task. And although you are moonlight here as a head judge, your day-to-day job, your 9 to 5, is with ELO 2, is that correct?
The rumours are true. I like to say that the Australian Rover Challenge is my night job, and my day job is for Lunar Outpost Oceania, who is the LO in ELO 2, the technical leads for that company based in Melbourne. And yes, we're trying to build a rover for the Trailblazer mission. So we're currently in stage 1 of that process, and we'll be finishing that up towards the middle of the year, and then crossing our fingers that we'll be selected for stage 2, which will see us actually construct that rover and send it to the moon.
So in terms of really understanding the relationship between this challenge and developing a rover for the moon, what are some of the real world challenges? I mean, there's many, but one of the really specific challenges that you yourself or your sub-team as part of LOO are facing right now that are being explored by the rover teams as we live and breathe?
Yeah, great question, Dan. So we've been in close contact, and the Australian Space Agency has been a partner of the challenge for quite some time now. And so we've been able to work with them to almost sculpt the competition to be exactly, mimic and mirror what the Trailblazer program is. So a lot of the decisions that we make in the rules are to make sure that the teams are getting that vital experience. Anything such as the visual things that teams have to deal with. I'm just looking out over here, taking my sunglasses off for this, and the soil that we have here is extremely bright, which just means calibrating your vision systems is so important, so you can actually make out objects and things like that. We did see in some base station footage previously of some camera feeds that do get washed out because of that bright light just so easily. Remote operations, mobility, comms, electrical, software, everything is all the same. The same challenges crop up time and time again. And so the students who are here competing in this challenge are trying to address those same challenges that we're facing at work to build a lunar rover. Obviously, we have additional constraints relating to redundancy and robustness to make sure, because we don't have interventions, we don't have repositions on the lunar surface. Once we send that puppy, it's away. We cannot do anything.
So I guess having addressed all those challenges, and with all your experience having led a rover team to some really important podium finishes over at the University Rover Challenge, but more importantly, your experience now as an important engineer developing this rover, and your experience as a judge, what's some advice that you would have for a lot of the teams having seen their performance across the 4 days? I'd be really curious in terms of maybe advice for the technical team and maybe some advice for the soft skills as well.
Yeah, can do. So one of my titles is systems engineer at work. So of course I'm going to come to you with some advice relating to that. So top-down approach to finding requirements. So one thing that we really, really want to see, especially in our written deliverables, is an approach to requirements that means that teams understand what is required of them to make a successful system. And it's up to them to define what that looks like. We'll outline basic things such as size, mass, constraints, as well as e-stop, LED indicators, and other things that they're required of the rover. However, it's then up to them to translate what they need from the point scoring activities into what their actual system will look like. One example is, there's points in the Australian Space Agency post-landing task for manipulating the buttons and other things on the processing plant that we have here. And most teams opt for a robotic arm, 6-7 degree of freedom robotic arm. But is that actually required? You know what I mean? Yeah. So it's like, I want teams to figure out, maybe that's too hard for a team who's just started. It is a really, really, really complex bit of kit to get something that complicated up and running. And maybe they'd be better off focusing their time and all of their team members and resources on getting their rover moving, communicating and seeing reliably, because that can net you a really, really large amount of points. In terms of soft skills, like you said, it takes an entire team, a diverse team, in order to be successful here, as well as just in the world and in the workforce. And so, you're going to come up against the same challenges again and again. And so practicing those skills such as communication and giving the students a chance to display their leadership skills is something that I really valued on my team, on my time at on the university team, and what I hope the students can be practicing right now as well.
Thank you very much, Henry. Those are some really key words of wisdom. And again, just to reiterate, as you were mentioning, what is required and how do your designs meet those requirements? So again, not trying to dive in and get so much complexity, see what other people or other space agencies are doing and being like, yes, we need to do that. Rolling it back, looking at the rules and understanding the challenge environment, which is so important that all the teams come out here and witness for themselves what the environment is like and what is actually required, not just what they think is required. So making sure that old analogy, KISS, keep it simple, stupid, if it works, is it really stupid at all? So again, just trying to reiterate, make sure that your systems are robust, they're redundant, because nothing ever works. As Joe mentioned earlier yesterday, it's sort of a Murphy's Law of you need to make sure you don't only have a plan A, but a B, C, D, and E, okay? You need to make sure that your systems are robust enough that under any situation that you can still net points or you can still move. And as you were mentioning earlier, making sure it's a bottom-up approach. Start with the wheels, start with the chassis, drivetrain, work your way up in complexity. We designed the rules specifically so that if you go ahead.
Sorry, I was just going to correct you. Top down for requirements. Start at the top. What does it need to do from a high level, and then flow that down,
and then work bottom up,
and then integrate bottom up. Perfect. Yeah.
This is why you're the engineer and I'm the geologist.
Awesome. Great to speak with you, Dan. I'm sorry that I can't relieve you of your commentary duties more often. Oh, hearing a bit of applause. I think the team might be doing something out on the field with their Rover.
It does look like
hopefully, it looks a little bit like an intervention. That's right. So the UniMel Rover team here is trying to debug the issues that they're facing and get their Rover moving. So we have our fingers crossed for them. Hopefully they can get up and running shortly and net themselves some points in this task. It's been fantastic to speak with you. Hopefully I'll touch back in. I'm really excited coming up after lunch. We have 4 teams left after the University of Melbourne, and they are currently the top 4 teams in the leaderboard standing. It's really going to be a hot one.
A red hot one, a real nail biter out here today, as of course we've got the previous podium finishers of Monash University being the reigning champs for the last 3 years, but that title is under question as Project Scorpio from Poland on a very aggressive lead at number 1 today. Let's see if that lead continues further into the mapping and autonomous task.
And then we've also got the Battle of Queensland in 3rd and 4th. UQ Space currently sitting in 3rd place and QUT Robotics Club currently in 4th. They'll all be coming to us in the Boeing Mapping Autonomous task shortly after the University of Melbourne. So please stay with us. It's bound to be an exciting finish. Back to you, Dan.
Thank you, Henry. So for those who aren't aware of the current intervention taking place across the lunar surface, there is a tradition. University of Melbourne Rover team have a long-standing tradition of their chassis representing a key icon in culture, spanning decades of youth and generation. We all know him, we all love him. His name is Big T. And for that side profile, I wonder if you can see who exactly it is, because that chassis, that color, for those acutely aware of a particular rail-bound vehicle, and of course, at the end of the Boeing Mapping Autonomous task, there's a little bit of flexibility in terms of what the teams can do with their available time. And I'll leave you with this sensational... Hang on, let me get an interview with Big T himself. So Thomas, coming back here for your 2nd year, how do you feel? And after 2 years on the circuit, you've made some phenomenal headway in terms of your chassis and your support. I agree. And in the off season, have you been working really hard? You're looking very slim, super light in terms of your overall design. I'm sure your trainers have been working you hard. What do you think? Well, thank you so much for your Herculean efforts out here on the pitch today. Thomas, you're looking in peak form.
We'll see what they come up with. I don't like those I kind of didn't want to go there, but you said it first. Also, they are doing for that. That one, come on.
So Thomas is in full control right now, navigating across the surface. So again, the local time is 12:15. You can see, as Henry was mentioned earlier, just how bright that lunar surface is as the sun bounces off the lunar regolith. 10 minutes left, really zeroing in on that arena. And again, just over 9 minutes left. Lots of time left to localize the remainder of these blocks on the surface. The team really battling it out against the difficult environmental and radio frequency environment of this beautiful Roseworthy campus in South Australia. And you can see the base station team there trying to navigate and figure out that map to provide to the judges. And it does look like they are going to attempt to ascend that mountain. University of Adelaide unable to ascend beyond that first few centimetres, and the University of Melbourne team making slightly better traction, but again, the loose lunar surface proving just how difficult it is to get that traction. Wheel sinkage becoming a huge issue. You can see that beyond half the wheel is buried deep into that regolith. The downforce inching ever slowly, every centimetre really critical.
Let's go back!
It is making its way up the mountain, king of the hill, inching ever slowly. And again, this is just highlighting some of the issues of trafficability and mobility that will be encountered by rovers out on the lunar surface with any steep incline, and that slight lateral slip showcasing the issues associated with really loose, low shear strength material, that material fluidizing out of the wheels down the ramp there. This big sand dune may look like it's too big of an issue, too big of a mountain for the rover to climb, loosely, laterally sliding down, really trying to dig those wheels in, get that traction, and it does look like it does drift away. Herculean attempt, fantastic effort from the University of Melbourne rover team. Phenomenal display of the mobility system to maintain its traction and not get bogged down there. That rocker bogie suspension showcasing that ability to maneuver over those inclines and obstacles. And again, plenty of time here left to either showcase the suspension, showcase the wheels, or continue to try and localize those blocks from that start orientation. Every coordinate they can give us, that's additional points. So again, for those wondering what is on the screen right now, you can see at the top a camera mounted for perception and orientation, and just beneath to the left of that, a speaker playing a unknown song. To the bottom of that, you've got a 3D printed additional extra spare tire made out of 3D printed black and grey filament. Behind that, the LED signaling that the Rover is powered and on. Beneath that, the folded sheet metal suspension, the chassis. At the rear of that, the diff bar in aluminium gold with its linkages back to those rear bogie wheels, transferring the force across the rear wheels. If that one rear wheels goes up, extra force and downforce is translated across to the other wheel, preventing it from tipping and slipping. And again, 6-wheel configuration. Lots of Rovers opting for either 4 or 6 wheels, whatever works. As some teams have shown, skid steering on 4 wheels is just fine. Independent actuation of each wheel on 4 wheels, also just fine. Independent actuation of 6 wheels, also fine. So again, lots of different approaches to the same task. Just over 5 minutes left for this University of Melbourne Rover team in their additional attempt at the Australian Rover Challenge. And it does look like the Rover is parking itself in its recharging bay on top of that lander. Again, this is what a Rover will have to do to return out from missions on the surface to try and recharge itself and reorientate itself.
Intervention to do that, that mutual center? No, we can you do it? Just,
Looked like the Rover has unlimited power driven to the wheels. It's going to attempt to ascend this dune just like Big Red out in Central Australia. The power being too much to overcome this loose dune. And again, this steep incline of powder. The angular repose of that heel being one of the largest inclines that we can get with this type of material. And of course, every granular material have a specific angle of repose, which is the angle that you can form if you pour out a powder onto a table or a flat surface. That angle of that pile is its angular repose, which is really important in determining its shear strength as well as cohesion. Just over 2.5 minutes left. Another lateral attempt at this dune. That base station dune really trying to address 2.5 minutes left. That really loose material accumulated on the surface. Windswept aeolian dunes.
The thing is, like, the moment we get we're just going to slide. That is the tallest one. Yes.
1.5 minutes left. Another target locked in its sights. It's going to try and ascend this lateral dune. A little bit of a smoother incline. But again, just as it ascends up with all wheels, all chassis, all that weight being translated back to the rear wheels, not enough downforce on those front wheels, no traction. You can see the amount of wheel slip happening here. Those wheels are spinning, but nothing is turning. This is just highlighting the issues associated with controlling the amount of power being driven to each wheel to make sure that it can regulate the voltage, change the amount or the rotations per minute, so the wheels don't slip at all. Traction is achieved.
Honestly, go on an angle. Seriously? They're you staying on all the time? You're like, yeah, guys, let's play. They started.
I'm just like, better at least play spotless.
Friday and Saturday, it's like 4 weeks. Go home, like drunk, and you get home, it's a wheel track.
But no one just like
Get stuck fully half on. We're wondering if we're going to try and like, get more money into uni by like doing super Yeah, I was like, I was originally promised.
This is where it started. And where you start. This is where you become tomorrow's
Cyber expert.
Physiotherapist.
CEO. Or musician.
This is where your time begins. Make history at the University of Adelaide.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People travel from far and wide to see this new city. We call it Moon Valley. The moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
Passed down to the generation. Huh? What you can do you are you are we are all. Maybe one day we can get good enough that we can get the Thomas one done so well. Thomas and but that's the pipe dream. Yeah. Something like this and just have the antenna as the are we chilling here until their presentation is done? Yeah. Okay. Yeah. I'm not gonna lie. And that's what started. This is definitely not all of us. Oh, this is people got back. Yeah. Do you want to do the group photo at 10? Yeah. Outside of the have the banner. Yeah. Or we can just bring over and just have. Oh, I get what you mean. You want after everyone's. Yeah. After everyone's back. So come back. Yeah, true. We can do a pose in front of the lander. Because last year we just strapped it to the back of the other.
That's going to test skills.
No. Oh yeah. I'm gonna get lunch. You could make a couple of mountain places. You need it every year. Oh, because I think I want. I mean, if it was put like around, yeah. Oh, right, we did our first. No, last year we just had it around 11. But the year before we went all the way to Bunker. Not from there. Like I said yesterday, we can have 3 people carrying it. I mean, it might be easier. I can go back and show you easier. It's easier? Wait, Albert, what's that? And who drew that Thomas face? I didn't think she did. Yeah. okay, thank you. Final day. Can we cut? Yeah, they've got some kind of their autonomy was all paper of the arena which they presented to me. No, so there's still 4 modules to come. Yeah, so Adelaide. And then now we have QT, UQ, Yeah, I did. I don't really want to think about it that hard.
Everyone follow us first. Cool. That was very funny. It was. And I managed to see it on the thing. Wait a minute, is that Daniel Ricciardo? Cool. So, current 12:38, guys start setting up in the day station at the follow road 5. That's just over 6 minutes. Comms on at 5 to 1, task starts at 1 o'clock. The starting gate for this task is down by this green and then red stakes just there. So red is X, green is Y, and one missing red box like that, and one yellow stone has been shifted a little bit. I'll make sure those are in the right place. You can have the rover anywhere within that box in any orientation. Cool. Setup is the same as every other day as well. We'll give you the walkies if you need it. Cool. We'll give you the walkies so you can communicate freely, move in and out of the base station as you wish. Take your time to set up, make sure everything's good. Because then once the base station door closes, the rover can't move. You are attempting to need or actively want to move. There are 5 placards down here. So go into points at the close of the data. So hopefully there's some sort of something in your base station or something we can do that like flashes up or something in your base in autonomous mode, if you exit or go into this mode,
We'll have one ready if you do. And you'll be standing sort of in front of the rocks. Is it? Yeah. I'm asking specifically because it's succinct. Speakers we can leave and play this one, two. Two's fine. We're thinking possibly putting a camera down that way, shooting back this way as well, so that we'll get a lot of people around sound. Do you think that'll be fairly good? Yeah, great.
And then I'll invite all the people.
Yep. I think that would be contained within the rocks. So,
if you want it to be, we just make it happen.
We'll see. I mean, we'll have it in view as well. We'll definitely, when it comes to the presentations, if there's any views, if there's a big room out there, it's much better for the shot if people don't have it.
It's basically like a rover. Slightly more documentation and rigor. Yeah, more documentation, more rigor, more pain in the ass designing things to actually put on. And then like, significant.
I'll go back.
Oh my god. Well, yeah, the final. You don't care. I was doing 4 years.
Oh yeah, so just let me know. Yeah, do let me know about because what I'm planning on doing is moving the electrical moving the speaker.
We are. Yeah, we're right. It's very satisfying when you like get a system that is like more reliable than what you get from very slow. Yeah, it's all the connectors, most of the internal connections are all port to port. If you exclude the science they remade one of the and they remade it with the exact same bugs. Like they were remaking it to fix some bugs that had to be like filed.
But the judge was not using the land like doing like the leader the reason behind and then
like everyone has to do it. Yeah, I'll write it. bright shading.
Yeah, it's still like a
Yeah, you should really let people know that.
yeah, and then big pop up like
How's the day been?
As I was doing it, I was like, so when we actually have like
we all know
coincidentally aligned or deliberately aligned.
Yeah, I remember seeing you
Probably like
Which might be a bad idea. Very, very So we work it out, that'll get us to my place at 1:30. It's work from home, so. Yeah, I know.
Yeah, no, right, that's what it's not going to happen.
It can fall off now.
Chloe, have you had lunch? Yeah. Did you get a thing?
Do you want a can, Will?
Christoph, have you had lunch?
Yeah.
Did you get a thing?
No, I just stole snacks from eating Adelaide.
They were offered. He wants some? Sure.
I wanted to ask for one, and then I just kept coming back.
You can manually drive but it's one of those things that drive around and feel like across the flag, like go find a waypoint and go to it.
you guys know where all the extra ones are, don't you? Yep. Yeah.
From some of these
Maybe have like separate powering users, which you guys maybe powering users, which you want to hold it. We have those two One thing I've realised is having the competition here in Adelaide is actually tracks from our school. Tracks the other teams, they have
like they're dotted around the field. What do they actually do work?
So the girlfriends in the playing users group at Adelaide, since they're only from the 5 people in America, they get 15 people set up for workshops. Because that's like, we want to be the ones who most work.
I'm starting to understand a lot more. Yeah, pretty good. I reckon there's like, you know,
we need to almost go like, I don't know if we took the logistics. No one's done. Maybe a tour and go through these regions, try it over there, or do you like, you limit this to, you want to roll in hot day, leave the roll in each stage, or could use space station group and have like everything there,
At this point, probably. We're still working on the spreadsheet to actually calculate. That should be ready soon. We can get this morning's here once the meeting's in. But it might change towards the end of the day. Okay. Good enough? All good.
Yeah, it's really hard to get stuff done when either you're busy or someone else is busy.
How was that? I was kind of hoping that we should have kind of like for that. Yeah, it was working on the table. Table was done. Yeah. That's nice. I was just doing mine and pretty well. Suspension is after I can't put that out. My thought was to do a full night meeting after we got 1 day a week. So I wanted to keep it working. Every project has to present what they've done in the past 4 months. They've done nothing better than for a 2 or 3 months, right?
I'll be around.
What are they going to do? That's what I need. But I mean, Adelaide tried to get up here. Really? As in, separate from the team. Yeah, well, like they're doing the thing. Anyone can reach out to them. No,
I'm just going to be standing there anyway.
Yeah, yeah. One was the Grand Prix. Yeah.
I'll be around.
Yeah, you got some here? Simran's gonna come, yeah? Whose Bunnings hat is that? Huh?
Nah, it's
I'm sure it's someone. No, I was joking. That's what I Yeah, come on. Cool.
I'm just not here to like
And welcome back out here on a very sunny 1 o'clock of the last day of the Australian Rover Challenge. And right now you can see the leaderboard up there with the final 4 teams to battle it out on the Boeing Mapping Autonomous Task, the current top 4 teams on that leaderboard. So again, those last few points could be really shuffled up. And of course, we've got the 2 teams from Queensland battling out, very slim margin between them, 10-point difference for that 3rd and 4th place finish, that podium. And just above them, battling it out for that 1st and 2nd place finish, we've got the reigning defending champs, Monash University, having won 3 of the previous 3 competitions, and with a very sizable lead above them, Project Scorpio from Poland coming in and absolutely dominating the circuit over the last 3 days. So it's great to see this Polish team really coming back after a year of development, improving their Rover, improving their systems, making sure it's super redundant, reliable, and boy, has it paid dividends for them. However, this is the lunar surface and Murphy's Law does apply. Anything can go wrong and something will always go wrong. Which team can overcome those odds and secure those points and let them secure their title as champions of the Australian Rover Challenge? Brought to you, of course, by the University of Adelaide out here in the beautiful Roseworthy campus in sunny South Australia. And boy, is it sunny today. You can see that picture-perfect blue sky, not a cloud in the sky. And all that sunlight really burning down, reflecting off this bright lunar surface, making it really difficult for the rovers to use their navigation and optical systems because that huge amount of reflection bouncing into the cameras, making it really difficult to determine which object is where, how far away they're from different obstacles. And right now on the screen, you can see that bright orange 3D printed hub wheels for the QUT rover team, of course, from Queensland. Time remaining 36 minutes, 4 minutes into their task time, starting at 1 o'clock with a total of 40 minutes available, finishing at 1:40.
Yeah, will do. Thank you.
See up on the screen right now that Pelican case showcasing the huge amount of pre-built, predefined, hello there, predefined amount of systems from that QT Robotics Club. And it's great to see this pre-deployed system offering a huge amount of readiness and deployability in terms of having those built-in controllers, those joysticks. And again, every team here having a different approach to the same simple question. How do you drive? How do you interact with your rover? Some using PS5 controllers, some using Xbox controllers, some using joysticks. It really is up to the operator because it is the operator's decision on how to best interface with that rover. And again, the amount of screens, the amount of systems, and of course the choice of materials. How many wheels do you use? The rover at the moment, those 3D printed high-vis bright orange inner rims looking like they're solid PLA material. Can I get a thumbs up? Is that PLA? That is PLA. No? PETG. There you go. And then an outer flexible rim. Thumbs up? Yes. So a lot of teams taking advantage of the options of different material selection that are available to them. And again, that rocker suspension system, those aluminium linkages transferring the weight of the rover just evenly the frame right now. And this is Project Perseus, the Perseus rover from QUT. And earlier we saw yesterday the Talaria rover, that little tiny swarm rover being deployed by QUT, the first demonstration of a deployable mini rover at the Australian Rover Challenge. So it's fantastic to see the teams really pushing the boundaries of what is possible, showcasing the utility of multiple deployable swarm rovers. And again, why would we want multiple rovers? Well, it offers a lot of things and benefits in relation to offering additional perspectives. So if you have something going wrong with your core rover, a little deployable rover with a camera can be sent out, provide a different third-person perspective. And again, speaking of cameras, that security camera mounted at the top of the mast there, just beneath the tiered LED light, which offers the field team and the judges confirmation of the status of the rover. And just to the left of that, that 5 gigahertz radio antenna. Can I get a thumbs up? Is that 5 gigahertz or 2.4? A little bit of both, no comment? Yep. So it's great to see, again, teams using different radio bands to transmit and relay all that information there. And it does look like a bunch of zip ties holding things down, securing the fort. Lots of teams relying on zip ties and duct tape, again, because it keeps things stable. Yes, those are custom zip ties, secured and purchased from locally sourced products. Again, those zip ties offering a huge amount of flexibility in tying things down, keeping it secure. And again, lots of rovers held together by zip ties and a dream, having been sent over to university challenges around the world. And again, up on the screen right now, you can see that rear diff bar with those vertical rods of aluminium, again, providing a differential distribution of load. If one of those rear wheels gets lifted up as it traverses over a rock, it translates that force down to the opposite wheel, preventing the rover from tipping over or flipping over.
I'll bring it out. Oh, yeah, I'll bring it out.
And for those of us tuning in for the first time, hello and welcome. My name is Daniel Ricardo, and you are watching day number 4 of the Australian Rover Challenge, brought to you by the University of Adelaide, hosted here in Roseworthy, sunny South Australia. We are currently watching the base station team for the QUT Robotics Club. The team, of course, being split up into a base and a field team. The field team's activities are responsible for setting up the rover before the task and performing any maintenance in case the base station team calls for any intervention. And of course, the base station team can also call for a new rule that we've introduced this year, a reposition, in case the rover gets stuck at any point. The field team can call for a reposition. However, this applies to previous tasks, whereas in the mapping and autonomous task, a new rule set applies. So if you are interested in joining a team, starting a team, getting a little bit more familiar with the rules yourselves, feel free to check out the Australian Rover Challenge website, where you can find all of this and more for those part of industry or sponsors. I'd like to quickly shout out the Australian Space Agency for sponsoring and hosting the post-landing task that we had on Thursday. The ELO 2 Consortia currently building a lunar rover for the Australian Space Agency's Artemis mission, or proposal to provide a foundation services rover for the NASA Artemis mission coming up later in this decade. They've, of course, hosted the excavation and construction task that we had on Friday, where the rovers had to go out, dig up some regolith, transfer it to a regolith transfer mechanism or a hopper. And, of course, the rulings and wordings of this task being identical from the Trailblazer mission report or the guide report. Being hosted from Western Australia and, of course, all around Australia itself. So 2 fantastic consortia, many companies vying to be the ones to build this Australian rover and be the first ones to demonstrate arguably a really critical point or moment in human history, the transaction of space resources. And hello out to the crowd, welcome. Thank you for persevering this brutal heat, this sunny weather, of course, making it a phenomenal event. No sign of rain anywhere today. Of course, we did have a little bit of rain last year, making us modify the ruling so that rovers can operate under any weather conditions, be it hot and sunny like today or cold and windy and wet as we've had in the past. And again, the local time is 1:12. The task time for the Boeing Mapping Autonomous Task, 40 minutes. And out on the screen right now, you can see the QUT rover out in the bottom right next to the lander, near its start gate for this task. And you can see that green arrow with the little bit of a red arrow showcasing the origin point, that 00 reference frame. And the rover's job today is to leave that start gate autonomously, which just means the operators cannot touch any system or keyboard during an autonomous portion. It then needs to drive around the field autonomously and identify the text and location of placards or little pieces of paper that we stuck out on the field. And in addition to that, localize and orientate itself whilst it's driving, mapping simultaneously, and in doing so, localizing the coordinates of these colored blocks. And you can see scattered around the field, these colored blocks, red, green, blue, and white. The rover's job, or the team's job, is to tell us where these blocks are on the map they make. And you can see on the screen right now, that blue block, just an example of the size and scale. The rover needs to go and find those blocks and then include that in a map that they'll provide to us at the end of the task. And the task, of course, being 40 minutes, followed by 10 minutes of data analysis, and then 10 minutes of a presentation with one of the head judges and our sponsor for today, Boeing, where the team needs to justify the validity and utility of their map and why they chose a specific data format. And again, there's a clock, 25 minutes, just over half the time remaining for their task. The field team currently deciding or deliberating possible pathways to approach this task. But of course, the field team and the base station team cannot convey information. They're currently still in their setup time. And the base station team, once that task start time has begun, the base station is sealed and no additional information can go in or go out. This simulates what it would be like to operate a rover on the lunar surface, with the only information being given to you being conveyed from radio telecommunications from your rover to an antenna back on Earth. Now, to help with this, the moon also has various orbiting satellites which act as communication relays, making with us back on Earth. And a fun little fact, did you know during the Apollo missions, where we sent humans to the moon for the first time, the first people in the world to view photos of Neil Armstrong going down that lander and touching on the lunar surface was in fact here in Australia. As based on the orientation of Australia to the moon at the time of the lunar landing, we were the first ones with the best orientation of our radar dishes to get those images first and then relay them over to Houston, Texas.
Second is autonomously imaging the placards. They were indicated on the map that we sent you last night. There are 5 of them scattered around the pitch. You can see kind of one in the back of the lander, one in the rock landing, and then the other 2 are not visible from here. You can only score points for imaging those during the autonomous phase. There are no points for the imaging those during the non-autonomous phase. The base station judge what counts as imaging. In general, if you're quickly handing the camera over, that won't count. Ideally, the camera can sort of relatively in frame. Yeah, that's fine. If it's like smeared to shit to motion blur, then that's probably not going to get counted. But yeah, if you can go back and view it, then that's fine. The second part is then the more exploratory mapping. So this can be done in the autonomous or non-autonomous phases. There are more points if you do it autonomously, and that is collecting the coordinates of the colored blocks that are scattered around the screen. So that we move from where they are to this team. We've got a different configuration for each team. In the base station, you get access to the booklet, which is the Y coordinates of the colored blocks, millimeters per unit, based on the coordinate origin of the map that we provided last night. You get points for your group, more points for your or actually double points. Autonomously versus non-autonomously. You can do some of the blocks autonomously and some of the blocks non-autonomously. The base station does record
lock in all of your autonomous answers before exiting specifically located block in your first phase. That could count as long as you need to finish that map and bring down the results before exiting. You would have something to do on the side while you then start. It's like the whole team is Then afterwards you'll have the 10 minutes to prepare the presentation, which is when you're presenting to me the map, which tracks the most points in the section, but also the design and justification of the components of your autonomous systems, the guidelines for that, and where you can see all the rules. Unlike the space resort presentation yesterday, the base station remains closed under base station conditions while you're preparing the presentation. So, like during the class, people are welcome to leave the base station, and if they do, they're not allowed to return. So you will have to be if you are in the base station. You're on the class. Interventions, you can't call intervention during your autonomous phase. Do call one anyway and immediately enter the non-autonomous phase. Readers will be notified what task because mapping the points. Collision. If you collide with any obstacle, that applies whether you're in your phase. So the small natural rocks don't count. No, they count like they're obstacles in that you probably want to go over them, but there are no penalties. Before you call the bus starter, so you get everything set up, do your final project or whatever. If you wanted, you would have probably myself now yourself, otherwise everyone. But you have to pick at least one ideal probably. Any other questions? Sorry.
And as a reminder, it is 1:21, the start time of 1 o'clock for QUT. They've yet to leave the start gate autonomously. Again, if they can make any distance out of that gate autonomously, again, up on the clock, 18 minutes left, they will get those 5 points initially, followed by 30 points available for looking out for those placards. If you can read the content of those placards from the Rover, then you will get those points. And lastly, exploratory mapping. You can identify the locations of those blocks. And the overall goal of this task is ultimately to give the judges a map. Now, that does sound simple, but the complications associated with that is your Rover is starting from somewhere. And as you drive, you need to simultaneously avoid obstacles, navigate around in a search pattern. And it does look like the base station team has put their hands off and maybe initiating the autonomous phase very shortly. And again, circling back, navigate the course, avoid obstacles, and simultaneously map. Now, how do you map something in regard to providing absolute distances? Because you've got so many issues associated with what do you localize against? Where's your zero frame? How far did you actually travel relative to how far your Rover thinks you traveled? These are all really difficult questions that are being addressed by these students out here today. but will have to be addressed as we return to the moon with the Australian rover, because there is no GPS, there is no 4G, Wi-Fi or wireless out on the lunar surface. So localizing yourself, providing your own communications network is really critical, which is what Lunar Outpost will be demonstrating, in the not so distant future, as they've partnered with Nokia to provide a temporary 4G network out on the lunar surface, providing a lot of pathways and bandwidth in terms of what you can do in communication. Look like we do have the initial movements of the QT rover potentially leaving the start gate. Again, to be awarded those 5 points for autonomous exit, all wheels and the full contact of that wheelbase needs to be outside the start gate. And that start gate is delineated by that initial wooden L section showcase, which is the 0, 0 reference frame, coming into screen now just on the right. And there are some additional markers outlining a 1.6 by 1.6 meter square, and that is the start gate it needs to leave. So it's currently sitting in this square gate, and in order to get those initial 5 points, it needs to autonomously, without any additional human input, leave that start gate and then navigate across the surface, look for those placards, convey that information to judges at the judge presentation, as well as simultaneously map and localize the location and coordinates of these blocks, avoid obstacles, and of course somehow do all of this in less than 40 minutes time. And again, so many teams today have been showcasing just how difficult it is to get operations working, showcasing that this is no easy task. This bombing, mapping, and autonomous task is not easy. However, each and every year we do see leaps and improvements of each team. So next year, really looking forward to some of these issues being ironed out and looking at the performance of how teams can improve these now mature rover systems. And as Henry was mentioning earlier, that bottom-up approach of making sure that your wheels work, your chassis and your mobility system is rock solid. And it does look like that rover is taking its steps out of the start gate. And again, a quick look to the base station before. No hands on the keyboard, which means this is an autonomous attempt, potentially. Or not. I don't know. 8.5 minutes left for the team. They have two options here. They could be attempting things non-autonomously with hands on the keyboard, or autonomously. Again, only points available for leaving that start gate autonomously. But they are able to, with controls, hands on the keyboard, able to navigate across the lunar surface and attempt to simultaneously map where they are in relation to where they left from that start gate, and of course the location of those blocks, those colored blocks, those red, green, blue, and white blocks out on the surface. And if you can see them, point them out.
That's really helpful because I'm not. Oh yeah, he's kind of close. Yeah, he's about to set. We just started a tradition. Yeah. Are they? No, that's Baptist. There we go.
Yes, they're all white.
Is 1:36, 4 minutes remaining for QUT's attempt at this Boeing mapping an autonomous task. And again, the rover currently traversing over to one of these blocks in the far bottom left corner, just behind the processing plant. And you can see, just for scale, the size and color of those blocks in relation to its location on the lunar surface, and just how bright that material of this sandy lunar simulant is, and scale of the rover relative to the block. And that processing plant at the rear, just the front for us from the crowd's perspective. And again, 3 minutes left on the clock. Every point that they can provide here in relation to providing more accurate locations in the XY coordinate grid are really critical, because in relation to where the rover started, that start gate over just to the bottom left of the lander, and now where the rover is, all this time, the rovers had to be trying to figure out how far it has traveled and what the absolute accuracy of that is into how far the rover thinks it has traveled. .40 left on the clock. The QUT Rover showcasing just how good that suspension and wheels are. And again, those large wheels, that huge wheel diameter, really paying dividends for allowing the system to maintain its traction and not become stuck in the loose sandy material. And it may look like the ability for it to really maintain traction due to some velocity control, but that just means that as the Rover moves, whenever the operators tell it to move forward or turn, that each wheel gets a separate unique voltage because each wheel needs to turn at a different rate. And if you don't control the amount of voltage going to each wheel, then you get a lot of slip because every wheel doesn't need to turn at the same rate when going forward or backwards. Sometimes one wheel has really loose, slippery surface and others don't. So again, huge congratulations to the QUT Rover team. That is the end of their task time. Let's get a huge round of applause. Congratulations. And again, thank you for coming out and spectating out here in this absolutely gorgeous but brutal sunny day, Roseworthy, South Australia, brought to you by the University of Adelaide, as well as our fantastic sponsors, ELO 2, the Australian Space Agency, Caterpillar, Mini Mammoth Games, Boeing, CSIRO, SASIC. So right now, carrying away the Rover team, the QUT Rover team, and up on the leaderboard right now, just showcasing this nail-biter finish between UQ Space and QUT, the two Queensland teams battling it out for that third place podium finish. Of course, just a Project Scorpio, hailing from Poland, their second time at the Australian Rover Challenge, and boy, have they come out arms really going hard in trying to scrape every inch, every point here, and dominating the circuit in yesterday's iSpace Space Resources task. And again, third and fourth, not even 10 points difference, which means if UQ Space or QUT are able to secure those vital points from leaving the start gate autonomously or localizing in terms of within just a small margin of error, less than tens of centimeters of the location of those blocks on the map, as well as their ability to answer questions from the base station judge, that point difference of just about 10 points could fall really, really rapidly. So again, it is critical that every decision you make on today's final task could secure you that podium finish at the 4th Australian Rover Challenge, brought to you by the University of Adelaide. Thank you very much. And as a reminder, 1:45 is the task start time for UQ Space. The field team currently setting out the Rover, that fantastic redesign, that slimmed size and mass minimized chassis. And you can see right now another attempt of the rocker bogey, this time with the bogey sticking out and the rocker at the rear. And just as I mentioned before, that slim folded sheet metal UQ Space branded chassis, the big e-stop, that big red button that every kid wants to press. That will cease all power to the rover, ensuring that in case of an emergency, we can cease power to the front of the rover. You can see that big excavator payload, that bucket excavator with linear actuators allowing it to pivot up and down and reorientate itself. And they use that rover to be sent to the moon, and potentially one of the consortia to be selected to demonstrate the first transaction of space resources ever, which will be the delivery of regolith to a NASA payload to demonstrate oxygen extraction on the moon. Now, why is that important? Because without resource generation in situ, which just means in moon, we would have to send resupply missions constantly to humans out beyond low Earth orbit, which is of course costly, risky. So this is why ISRU, in situ resource utilization, is such a key technology that we need to demonstrate and develop as we venture to the moon and onwards to Mars as part of NASA's Moon to Mars program. And of course, the precursor to that is NASA's Artemis mission, Artemis being the sister to Apollo, seeking to put humans back on the moon, this time to stay. And I believe the Artemis 3 mission will return humans to the moon. But before that, we need to demonstrate some really key infrastructure and technology, like extracting oxygen from lunar regolith. Now, why is that important? Because it has huge downstream benefits for here on Earth in terms of demonstrating some really energy optimized, low mass, robust systems built for harsh environments that can extract resources from dirt. Now think about the benefits of that in terms of being able to extract metal, oxygen, water from things that are drier than sand.
We put the orange at some point. We lost it. I remember like 5 yeah, I think we tried to restart. Crazy. Really crazy. I don't know how much it was down. It was running for some of it, but not much of it. Yeah, but then it's like, yeah, it's very just like raw odometry, like the full drifting kind of odometry. Yeah, and I don't think he ever got the we have a total of 3 IMEs, so if we could use all of them together, but depends. Yeah, but we didn't actually get there. We just had I think it was just the base set odometry, like as in just the Z time, which is, last time we also had.
So the time is 1:47. The official start time for UQ Space being 1:45. And again, quick update to the leaderboard. With several of the teams having completed their attempt at the Boeing mapping and autonomous task, their leaderboard has shuffled around a little bit. Adelaide University in number 5 in a comfortable 24-point lead above University of Melbourne. And again, a very narrow 7-point margin between Uni Melbourne and RMIT, followed by Swinburne University. Of course, Swinburne being their first debut here at the Australian Rover Challenge, so really phenomenal effort from them, followed by Team Atlas all the way from Bangladesh at 92.1, and of course, University of Wollongong at a very close margin, just behind 70 points at 69.5. University of Wollongong, again, just like Swinburne, their debut attempt at the Australian Rover Challenge. So huge, phenomenal effort from everyone involved, getting not only a Rover up and running but functional on this pitch, but the fact that they were able to get a team organized, a workshop secured, budget, money allocated to them, and then all the operational logistical requirements in forming, growing that team and getting over to Adelaide. Huge effort in less than a year, sometimes only several months. And that UQ Rover team, again, QUT and UQ battling it out for that third place finish. The performance of UQ now really dictating what they will place. A 10-point difference between the two of them. This this Queensland rivalry really heating up as more Queensland teams are stepping up to the podium. Last year, of course, we had UTS, University of Technology Sydney, unable to make it this year. However, several more universities in the lineup for 2025, and boy, will it be a big one. More universities, more students, growing every year. If you are interested in joining or starting a Rover team, please get in contact with us or check out the Australian Rover Challenge website. We'd love to get involved and help you experience what it's like to build a Rover or be part of a team. And again, if you're wondering if I can get involved, or maybe if I'm not an engineer or a scientist, how can I get involved with opportunities like this? Well, as long as you have a passion for space or a passion for teamwork, you can play a role in these teams. And some teams have over 100 members spanning every discipline and background, from business to medicine to media to operations, economics. As long as you can be part of a team, learn those soft skills, those soft interpersonal skills of working in a team under complex environments across varying disciplines. Stressful environments, often time critical, transiting all the way interstate, often overseas. Now, these are the skills that are expected of these students and really sought after by a lot of the companies, including the sponsors of the Rover Challenge, being able to work under time-critical environment, under operational conditions like this. If they would like to send something to space, then these are the perfect skills that are required, which will really get them over the line when going towards an interview.
Impressive to remain positive. I mean, stuff goes wrong. Realistic performance anxiety.
Yeah.
There's a lot of sharp on.
That's crazy.
Yeah.
Yeah.
Yeah. Proof that a backup plan can work.
Yes. Every camera except for this room. I don't know if you've heard that.
Yeah.
Every camera except for the other laptop.
And that was the backup we just added.
Problem solving under pressure.
Yeah.
And it's safe.
It's safe. In some. Man, yeah. But like, yeah. So like we tried to start like 6 times or something.
Because autonomy kicks up when the robot makes it.
And then it
I don't know why.
and we don't even know why it
And all hands on heads right now. No hands on keyboards. The Rover is moving autonomously out on the field. It's great to see that from the UQ Space team. And again, every point here does matter to help eke out that top place third podium finish. And the base station is quiet. The crowd is quiet. Watching this Rover navigate itself out of that start gate autonomously. Absolutely phenomenal effort from the team. Huge amount of growth in such a short amount of time. And as a reminder, highlighting the complexities of how it is to not only make a Rover, bring it out here, get it moving autonomously. And as Henry mentioned, it's that bottom-up approach of making sure that those core Rover systems are functioning. And again, so the Rover right now trying to make its way out, probably performing a searching algorithm, looking for either colored blocks or placards. And if it is successful in finding one and localizing itself to figure out how far it's traveled from that start gate, and then describing to judges the location of those colored blocks. And you can see the red, green, blue, or white colored blocks embedded in the sand. If it can tell us where those blocks are in relation to the map, they'll be able to score points. And right now, up on the screen, you can see the graphical user interface. This is the view that the rover operators can see coming through their cameras. And of course, they're not able to interact with any of it right now as they're currently in autonomous mode, but showcasing the issues or difficulties associated with using those cameras and the huge amount of contrast in shadow and illuminated surfaces from this really bright Australian sun.
Also, it's all percentage and you can't feel negative, they stack. But once you hit 100, we don't take your hard-earned previous points. You can't have negative benefit from participating. No. If you'd have scored a bunch of points and then got negative benefit,
You wouldn't like take the points they could have had on money.
We're taking out your science. What do we encourage giving it a go? Even if it all goes wrong?
Yeah, I feel like penalties are pretty brutal this season. They're being nicer.
I think for the most part, penalties are right.
So you're giving them
I see the penalties.
Get your Rover.
It's like, it's really encourage teams to solve without.
Yeah, I mean, we're on the move.
Exactly.
You don't jump in.
It's a bit. Although the science penalties, you get given them, man. Everything else is fine. But the science ones, we are then.
They really love hearing it.
Where we want it to go, like goals. Those are like we want it to go in front of these roles.
But we get like a trade-off, right?
But we
like,
try to do that. Evaluate how we get to the
So the manual load is only for that specific type of car. It's if you get to know enough. You would have always
Was that why?
For us, it was basically if we try, we have a really low chance of getting 30 points, and look high chance of losing 15. Like winning 30.
And the views right now, this is exactly what the base station team are seeing from their rover. And you can see them watching back the footage collected from that rover's autonomous traversal across the surface out of the start gate. So again, each of these views are one of the cameras mounted onto the rover, providing a different perspective. And you can see in the top left image, hidden in those rocks, that placard. And it's the team's job to tell us, the judges, the content of that placard, what type of image it is. And if you squint really hardly, you can probably see what it is. It's too far for me. On the top right, you can see that view from the top of the rover into that, directly into that big bucket excavator. And on the bottom left, you can just see the issues associated with collecting those shadows. And right now, this is the team zooming in. Now, this is exactly what's going to happen, or has happened, on exploration missions to Mars or the Moon. You have really huge issues with resolution and field of view. How far can you see using the cameras that you've used? Now, what exactly is that image? Maybe you can tell us. If you're an astronaut out there sitting in the bleachers, keep it to yourself, because the base station team can hear us. And again, on that top left screen, you can see that processing plant coming into view. And if the team currently collecting all these images, and it's great to see the workflow. So yeah, what is that? I really don't know. And again, points. They've done all this autonomously, so points available for conveying to judges what is on the content of these placards and where they are. So huge, huge congratulations to the team. It's great. Again, big shout out to the production team for making this view possible, showing to the spectators just this workflow. Big shout out to the whole events team for making everything possible here, providing us with shade, making sure that I'm able to speak into this mic and you can all hear me, and for running everything. We're absolutely loving it right now. And again, 1:58 local time. Don't know what time it is on the Moon. 26 minutes left, and if the team continue to reattempt this autonomously, they may be able to get more data, but again, that beautiful view of that optimized chassis and suspension and wheel system. Again, each of those wheels, much like every other team, 3D printed. A relatively small wheelbase, but currently haven't had any major issues, highlighting the ability or the advantages of going slow and not varying that voltage to the wheels too much so you don't get a lot of slip. They've had no issues with traversability yet.
At all.
So the team now may be determining if they're going to transition to a non-autonomous and continue traversing across the field and trying to map out the location of those blocks. They'll also be collecting the data reviewing the data they've just collected to provide to judges in the upcoming judge presentation, where they'll be confirming the location and content of those placards as well as the blocks. And this is trying to get the teams to really validate or demonstrate how the data they collected is valid, is also justifying why they're providing the judges with a particular file type of a map, and also getting them to practice some really essential skills in communicating their findings, which is what we're trying to showcase here at the Australian Rover Challenge. It's not just about designing and building a system, it's about sharing that knowledge and communicating it effectively, which is why we've got the space resources presentation and the mapping and autonomous presentation. And it does look like the rover is in non-autonomous mode, as the rover is making light work of the surface. Just over 20 minutes in, we've got 19 and a half minutes left of this Boeing mapping autonomous task. And of course, UQ really trying to eke out every point here and secure themselves a position just above QUT. There was only a 10-point margin just before. These Queensland universities trying to cement themselves as the podium finish in this 4th Australian Rover Challenge. And after UQ Space, we do have Project Scorpio from Poland and Monash University battling it out, showcasing their prowess and capabilities in the mapping and autonomous task. And the rover right now traversing across the surface. And again, that view coming from the base station showing the 4-camera view of the cameras scattered across the rover, each providing a unique perspective, different vantage point of what is ahead of it, or potentially what is behind of it. And again, just showcasing some of the contrasting features from previous rovers traversing across, looking at the grouser or that tire pattern as it traverses across the lunar surface. And that information is actually really important as we're able to figure out a lot of the geotechnical properties of the lunar and Martian surface just by looking at the imprint of rovers and Apollo astronaut boot prints, looking at the shape, depth, geometry of those imprints on the surface. And again, the rover making really good use of its rocker bogie suspension, those large wheels, 3D printed grousers, allowing the sand to exit really freely.
Prodigy, that's what I mean.
Yeah, we are in 9. First year. Next year, what's the target?
Kind of mindset about how you do
Just about 5 minutes left. The Rover traversing across around the pitch, trying to localize where those coloured blocks are. The team successfully having completed a bit of an autonomous leg initially. We got a little bit of a sneak peek into the flow chart. Sorry, the flow, the process in order to evaluate and look at those data, review the data products. And just under 5 minutes left, the team deliberating what they can see out on the pitch. Every decision here could get them very dearly needed points and eke out that top 3 podium finish. The battling of the Queensland teams.
Yeah, that's acceptable. It should be. Obviously, Hey, now, come on, stay together, bro.
Different team.
Just hold up chat. One more. Just last bit.
You guys changed
So that was UQ Space finishing their task time in the Boeing mapping and autonomous task. They will be carrying their rover off the Challenge Arena, hoping they secured some points, able to find some of the coloured blocks that we've scattered around the arena for them. Looks like they had a little bit of fun at the end there, trying to make their way up one of the large berms that we had made on the Challenge Arena for us, testing out their chassis and mobility system to see how robust that was. You can see I'm loaded up. I've got my water. I've got my ice cream. Coming up next is Project Scorpio from Poland. They're currently sitting in first place. Let's see what they can do with this task and if they can cement that first place and get the win at this 4th Australian Rover Challenge.
Are you guys doing?
So welcome back to the Boeing Mapping and Autonomous Task for the Australian Rover Challenge. We have Project Scorpio from Poland lining up in our starting position on the Challenge Arena, about to get underway in this task. They are currently sitting in first position for the challenge, and we'll be looking forward to trying to secure that first place finish with a score in this task. So this task has three parts. The first part is that the rover has to autonomously navigate the Challenge Arena that we've got here and try and identify the placards or the little postcards with pictures on them and notify the base station judges where they're operating the rover from what is on those placards. The second portion is to find the coloured blocks that we've placed and dotted around the Challenge Arena and report to us the coordinates of those coloured blocks from the starting position that the rover begins this task in. The accuracy at which they're able to report that location corresponds to the amount of points that they will get. The third portion of the task is to host a presentation with one of our specialist judges, Lachlan, as well as Glenn from Boeing, and they will be quizzed on their approach to this task, as well as present the data and the map that they have captured of the Challenge Arena from the rover in the field. So, Project Scorpio, their task time has just started, so they've got 40 minutes from about now. They're going to take a couple extra minutes to make sure that the rover is ready to go, but we should see their rover leaving the start gate in just a few short minutes. So you can see Project Scorpio in their base station there, working hard to set up their rover. So whilst this is the autonomous task, it means that they're going to be sending different commands and programming the rover, and then they're going to give an indication to our base station judge that they're ready to start, and then they will be hands off the controls completely. And the rover will be completely driving itself and making its own decisions. I can't understate how difficult this task is because the rover has to have all of that behavioral logic built in and make its own decisions and make its way around the challenge arena by itself.
Like the other thing you can do, so if you had like an accelerometer and stuff, you can integrate the acceleration to get velocity. You can integrate the velocity to get distance, and then you know, and you can also use your data. But I know for a fact you can still have GPS connection.
So you can just see the Project Scorpio team members did just clear the field, which means that they are going to get underway very, very shortly. So the team in the base station will be sending their final commands to the rover, and then it should get underway autonomously and start navigating the surface. So there are a myriad of ways, there are a myriad of reasons why we have this mapping and autonomous task in the challenge. And so it's very applicable to space applications for a number of reasons. One of them is the delay in communications that exists between Earth and other planetary bodies. So the light delay between the Moon and the Earth is about 8 seconds, I believe. And so that means that it isn't feasible for an operator on Earth to be able to digest the information streamed from the Moon and react in real time. And instead, they will have to program the rover or other robot, which might be on the Moon, and allow it to make its own decisions with an objective in mind instead. Another reason why they need to be autonomous and make their own decisions is, for example, on Mars, where every so often, I'm not sure, 2 years or so, the sun comes between the Earth and Mars, and there's a period of quite a number of days where it isn't actually possible to send commands between the Earth and Mars. During that time, the only way that the rover would be able to generate any scientific value is if it is operating autonomously, making its own decisions, moving around the surface and trying to collect scientific data, which it can then downstream once it regains its connection with the Earth.
I just like the discrete integration algorithm. Like we did that in stats and
So the Project Scorpio rover is going to have a set of sensors. Oh, sorry, I'll stop you right there. We've got some great images coming through from the base station computer from Project Scorpio. And so that's showing the data input that they might have access to them. I imagine that one of the... Oh. And there seems to be some sort of image. Thank you, guys. I appreciate it a lot. They've got their base station input there, showing what appears to be potentially one of the obstacles in front of the rover. Potentially that red mark might be the rocks that are in front of the rover. I could be wrong. I am not sure. I don't have familiarity with this exact system. It looks like the team might also be placing waypoints on their map of positions that the rover may navigate to once they hit go and the rover begins to autonomously navigate. So the team still is in that commanding phase, which is applicable to if we were doing the same thing on the moon or on Mars or on another planetary body. We'd be taking our time, really planning out that string of commands that we would send to the rover, which the rover would then execute autonomously afterwards. So the rover here is probably kitted out with a number of sensors to try and gain information about its environment. So I know for sure that it's got a stereo camera on that horizontal boom between the two vertical masts, which has that orange 3D printed part holding it and facing it down towards the rover. So this essentially uses the same I'll call it technology that human eyes use, in that the two cameras are spaced about the width apart as human eyes, and the difference between the images that those two cameras are seeing can provide information, for example, on how far things might be from that camera. It's the exact same effect as if you hold your finger up in front of your eyes and close one eye alternatively, that your finger appears to be in a different position even though you haven't moved it whatsoever. That's called parallax, and that will give you information on how far away your finger is from your eyes. I can see the crowd there giving that parallax a go with their fingers. Go on, keep doing it. It is a fantastic day out here at Roseworthy, just north of Adelaide. The 2024 Australian Rover Challenge is at a new location this year at the Xterra's Analog Facility at the University of Adelaide's Roseworthy campus. It is a brand spanking new facility, and we've decked it out with some lunar analog soil for all of the teams to navigate on, drive around on, and complete this challenge. We've been absolutely blessed with the weather. I've barely seen a cloud in the sky for the past couple of days.
No, musimy kibicować. Dance with me, cheerlead.
If you gave me a shirt, maybe.
I'll give it everything.
How many different sources you could distinguish from each other?
I just want to go and like bring it to you. Like, oh, I can see my security.
So you can see there the base station judge Lauren is closing up the base station tent, which means they are ready to begin the task. We should see the rover moving autonomously at any point now. They've got 26 minutes left in their task time, so still plenty of time to investigate the challenge arena autonomously and figure out what they can about the surface and the location of the coloured blocks that we have. And it looks like the rover has started its traversal. So this is all being conducted autonomously. The rover has left the start gate. That's worth 5 points. And it's making its way over towards the processing plant on the left-hand side of our challenge arena. So if we go back to the base station, everyone should be hands off. There might be one person looking at a computer preparing their presentation in the future. But as you can see there, no one is operating the controls right now. The rover is just moving by itself, making its own decisions and moving around based on the camera feeds that it has available to it. So we have provided a map of the general area of the 5 placards that we've placed on the surface, the first of which is on the processing plant which the rover has approached here. So if they're able to show the base station judge an image of that placard, which is on that screen, on the front face of that processing plant, I can't see it from here, I believe it is an eye test chart, then they will get the points available for that portion of the task.
Wow, thank you so much.
That's good.
$2:30. Yeah, so the time was right. So there's 20.
So this is fantastic. We are viewing one of the outputs from the sensors on the base station. So it looks like that darker area that they just had the mouse over might be the processing plant. It's a little bit hard to tell. So the base station team will be analysing that information, but they won't be able to command the rover at this time if they want to maximise their points in the autonomous mode. So you can also see the camera feeds that the rover has there. They've got quite a number showing different perspectives of the rover. I believe the 2 down the bottom are from the vertical mast pointing out to the left and right hand sides towards the front of the rover respectively. The top left one looks to be from maybe that stereo camera image on the top of the rover, and the top right, I am not sure. It looks like there is some text which is upside down, and the word fail is in the top left. I hope that's all okay. Is that okay? Yeah, it's okay. The team has assured me it's okay. And again, you can see that it looks to be a point cloud image that the rover has generated. It's hard to discern exactly what features might be within that point cloud, and there is a green line which looks to be the path the rover has taken from the start gate to its current position.
No, yeah, that as well. But no, the problem was I wanted to use my actual board. That's when they discontinued it, and you need a power adapter. And power adapters surged the cost because when they discontinued it, and you needed them to use them on the actual point head. No, it will essentially. Yeah. Well, I have a 360. I have 2 360. But yeah, no, like they're good. Yeah, no, you can get them cash, you can get them cheap online. Connects are cheap. They're not ideal. They are. Microsoft still making a development. Yeah, it's okay.
Thank you. Sit down.
So it looks that the Scorpio team has exited their autonomous phase potentially. You saw them processing some images before. They had one of the placard, which is in the center of the challenge arena, nestled between some of the rocks, and then another image of the one on the processing plant. So now they're back working on the keyboards, processing those images, letting the base station judge know that they've found them autonomously, which will net them some points. And then I would expect for them to enter their non-autonomous phase, where they'll be able to manually drive the rover around and try and hunt down those colored blocks, and then report their coordinates to the judges. So again, it's hard to tell exactly what this is showing us. We've got it almost looks like red and pink jigsaw pieces on the top of the screen showing the field of view from one location. I'm not exactly sure what that is showing, but I'm sure that the team there is using that information to tell them information about the local environment to try and maximize the score that they've got. So it looks like the rover is moving once again. And if we go back to the base station, I would expect that they have their hands on the controller. So they are manually moving the rover now, have entered that non-autonomous phase where they'll go hunting for the coloured blocks. There's a red, white, blue and green block out there, which they need to hunt down and then report the location of back to the judges in millimetres from the starting position for this task. So it almost looks like the rover is heading back to the starting location. This could be to collect additional information about the distances of relative objects to that starting point. Of course, if you're able to navigate out and then back, taking those two measurements will give you additional information to hopefully come up with a more accurate result. Once again, they've got that point cloud. That definitely looks like the lander, the ramp of the lander and the solar panel. And so it looks like the... Oh, turn something off. Can you guys turn it that back on? The nice looking... They're shaking their heads. Okay, no problem. Keep doing what you're doing. I don't want to distract you. And they've got those different camera feeds coming into their base station. So they're navigating around the back of the lander. So remember, there are points available for generating a map of the entire challenge arena. There are points for the coverage of that map. So they might just be going for a little bit of a Sunday drive right now, seeing the sites, building that map up, which they're going to show our judges in the presentation and gain additional points. So folks, it's been good. I'm very excited to see how Project Scorpio go. We've got Monash Rover coming up soon in, what would it be? 25 minutes or so. And so these teams are currently placed first and second. It'll be interesting to see how it shakes out. My name is Henry. I'm stepping away from the commentary for a second and giving you back to Daniel Ricciardo. Daniel, why aren't you in Melbourne?
Well, I drove over here in my Formula One car and I made blazing time. And again, local time here in Roseworthy, Adelaide, 2:56. As a reminder, Monash Rover starting at 3:15. A phenomenal display from both of these teams, really flexing off their mapping and autonomous packages. Scorpio making excellent time. And I could see Nova coming into the judge tent for their weigh-in, for their check-in. And up on the screen, you could see that awesome digital elevation map with the color coding, and you can see the contours, that digital representation of this surface. Absolutely phenomenal to see from these undergraduate and graduate students who have designed and built these Rover over several years of iteration, hard work, passionate, late nights fueled by coffee and Red Bull. And one of the things I really want to draw your attention to is just how smooth that Rover is traversing across the surface, how each of those wheels are remaining in full contact, no slip as it turns. Really good control of those individual wheels. And again, keeping it really simple, just a simple rocker suspension, 4 wheels, nothing fancy, but really paying dividends in terms of that redundancy and reliability of always being able to move. Scorpio having no issues in either this year or last year with mobility. This year having opted for a fully 3D printed wheel, and I was speaking to the team lead earlier that one wheel took 5 days to print. Boy, would that be a nail-biting 5 days. Last year, of course, they did showcase the utility of using a simple thing like space fabric to try and get that traction, really minimizing low mass, low complexity. And the Rover going all the way over to the far corner of the pitch. And in the background, you can see some of those colored blocks, some of those rocks. and the Comstar processing plant really gently caressing around just the edge of that processing, that payload. And again, if they do collide with any of the rocks, the large fake rocks or the props, that is a 10% point penalty. So really gingerly making its way around, taking full advantage of those obstacle detection methods. Absolutely phenomenal to see from the Rover team. And as a reminder, they've got about just over 12 minutes left of their roving time. Up on the screen right now, that 11-minute countdown, 30 minutes into their 40-minute task time for this final Boeing mapping and autonomous task out here at the 4th installment of the Australian Rover Challenge in beautiful sunny Roseworthy, South Australia. And again, just on screen right now, you can see the rover and the scale of the hill out here on the surface exceeding 1.2 meters. And we saw earlier some of the teams attempting to scale that hill and barely making a dent, not even halfway up. Really highlighting how traversing up steep inclines on really loose terrain is not a simple challenge. And after these award ceremonies today, we will have some fun little events for you to tune into, and for the Rover teams all out there in the workshops, I hope you can hear me, we will be showcasing some tug of war, King of the Hill, drag races. It's all going to happen. Bring out your Rover. And let's see what it can do. As a reminder, the local time here in Adelaide is 3 o'clock on the dot. We've got Monash Rover starting their attempt at the Boeing mapping and autonomous time from 3:15 to 3:55, followed by a slight intermission with an award ceremony from 4:30 to 5 o'clock. And from 5 to 6, we do have that fun and games intermission of tug of war, King of the Hill drag races. Of course, all being done and executed safely with no people on the pitch to make sure that no one gets injured. Following that, for the students here, we then have from 6 to 7:30 an industry mixer and food. That'll be really critical. Just a few minutes remaining left for Poland's last attempt at the Australian Rover Challenge 2024, brought to us by the University of Adelaide. My name is Daniel Ricardo, and coming up next, we've got the defending champions, Monash Nova Rover team from Melbourne, Victoria, in their hot pink Rover. Again, Monash's time is from 3:15 to 3:55. Just about 6 minutes left for Poland to eke out these last few points at their attempt of the Boeing mapping and autonomous task. And as a reminder for you out there, if you're tuning in for the first time, welcome. You can see up on the screen right now that digital representation of all the data collected autonomously by that rover, them trying to process it, create that map so that they can hand to the judges. And all of this task is trying to get the team to give us, the judges, a map showcasing as they left that start gate, trying to map and navigate through the surface and localize the coordinates of various items of interest, including the location of blocks and the content of placards mounted to the various places across the field, including some wooden stakes and on the supply caches, like the processing plant, the comms tower, the solar array, or on the lander, scattered variously across the lunar surface. And each team did receive different instructions of what they had to image. And the teams are graded based on if they can identify the content of those placards autonomously, and also the accuracy of their coordinates for each of the blocks. And of course, they get more points if they do this fully autonomously. Autonomous being no hands on the keyboard, hands off the steering wheel. And just as we cross over that threshold, 5 minutes left for Poland, Project Scorpio.
Safety. Where's the bag?
It's on the science bench.
Oh, yeah, Chris,
If we make it a little autonomous robot with the sense of humor, there you go. That's the one.
And the team currently deliberating as they prepare in these final minutes. Just as a reminder, they'll have 10 minutes to process all the data collected during this task time, followed by a 10-minute presentation where they'll be discussing to the head judge for this task, as well as a sponsor from Boeing, on the validity of the data and justifying the utility of it, which is a great demonstration, an end-to-end demonstration of what real-world challenges these students will face as they progress into industry, not only designing these systems, using them out once they're deployed, but also justifying back to their project managers and funders to make sure that the long-term survival of these missions continue. And in that picture-in-picture, you can see just how good this Project Scorpio rover is. All those wheels making excellent use of their control over each wheel's velocity, making sure there's no significant slip as it turns. And that excellent crescent-shaped grouser design. The grousers being those extra surface or geometries around the rim of the tire. And for those curious, those tires are 3D printed, each taking about 5 days. And if you get a closer look after the team is all done, you can get a look into how those wheels or the infill pattern is this really spectacular infill geometry. It looks really cool. And up on the screen right now, that may be either a topographic projection where each of the colors represents a different elevation, or that might be different amounts of data. But it's great to see that this simultaneous mapping, that digital representation of the lunar surface, absolutely phenomenal to see from Project Scorpio. And again, big shout out to the production team and everyone who's made this event possible, getting us a glimpse into the base station's screens, allowing us to look at what they're looking, really helping communicate the awesome science and engineering that are going into these projects to showcase to up-and-coming students going through primary and high school. This is some really cool things that you can work on, and one of the more interesting things is no matter what discipline you decide to choose, whatever choice you decide to make, you do have a role to play in the upcoming Artemis generation as we return to the moon, this time to stay. Just about 30 seconds left. Let's see what the team decides to do. As in the past, all previous teams have attempted to scale that huge hill. Will Project Scorpio try and flex their suspension or continue mapping out the surface? They're really trying to eke out every point, use that manual control to navigate across the surface, really mapping out, localizing the location of each of those blocks, those placards. Again, extra points if it's done autonomously and partial points if it's done non-autonomously. Autonomous being no control, hands fully off the keyboard, and in the screen right there, that red block. And at the end of the task time, let's get a huge round of applause. What a sensational effort. The time is 3:10. Monash Nova Rover, the last contestants coming up today. Start time of 3:15. In the next 5 minutes, we'll be resetting the field and grabbing the rover off. And as a reminder, next 10 minutes, the base station team for Project Scorpio will be evaluating their data, preparing for a 10-minute presentation.
13. You don't, not 5 out of 9 or 10. No, 5 out of 9. Yes.
That's exactly how you get charged.
Rover telling
With time ticking down, Monash Nova Rovers attempt at the mapping and autonomous task officially start times at 3:15 with a total task time of 40 minutes. Hello and welcome back. My name is Daniel Ricardo. So we've got a spectacular series of rover attempts at this Boeing mapping and autonomous task today on this lovely sunny day out here in Roseworthy, South Australia on Sunday, which is the last day of the Australian Rover Challenge 2024. Thank you for tuning in and staying with us over the last 4 days. We've seen some spectacular attempts across all 4 of the tasks. Of course, being the Australian Space Agency post-landing task on Thursday, the ELO 2 excavation construction task on Friday, the Space Resources task on Saturday, and today the Boeing mapping and autonomous task, which we've had some excellent attempts at. However, we has showcased some of the limitations in terms of the design and development cycle and making sure that the bottom-up approach of getting your system really robust and redundant, always driving when you intended to, making sure that your communications and radio protocols are always working. Really this culmination, this layer cake of complex systems that need to work to really showcase and thrive in this task. However, we have had some incredible improvements over 24-hour periods as teams really innovate and spend so much time after their task attempt innovating and editing their rover overnight out here at Roseworthy as we close up the site at 10 o'clock. So the task time for Nova Rover has officially started. We will likely see a little bit of intermission here as the base station team set up and continue to prepare this rover for that autonomous traversal. And as a reminder, 5 points for autonomously leaving the start gate delineated by that, you can see up on screen right now, just beneath the bottom ramp of the lander there, that red marker. Now there's a red and green wooden marker representing an L. This is the 00 reference coordinate. From this point, the rover needs to traverse out into the great unknown of this lunar surface and map out its surroundings, whilst also avoiding obstacles. So, of course, being awarded points for whether or not you can identify the content and text and accuracy of placards and blocks scattered across the lunar surface. And for those looking at that rover, the hot pink 3D printed wheels with those crescent-shaped Grouser geometries, really the culmination of several years of iteration and development on that wheel design. 3D printed outer rim, aluminium spoked inner rim, providing a lot of simplicity, reduction in mass because there's so much airspace there. However, all that load is still transferred to that inner hub, that inner aluminium housing containing that motor. And not only that, individually pivoting wheels, and we'll see just how spectacular that individual motion comes into play. And we've seen the display of that really unique maneuverability, that ability to pivot on a dime, have different turning arc circles, and also lateral movement. So the base station team here continuing to set up. Start time of 3:15, 3.5 minutes in, now 4 minutes. plenty of time for the team to still leave this start gate autonomously, continue the autonomous portion of their task, locating those placards and the content of the placards. And then also the coordinates of the blocks that we've scattered out onto the surface, the red, green, blue, and white blocks. And the local time is 3:21, and up on the screen right now you can see the hot pink folded sheet metal chassis of the Nova Rover team. And you can see that rocker suspension as well, and just out of frame the 3D printed wheels in front and center. You can see a little passenger. And of course, we are on the moon. And that little teddy bear there in a handmade spacesuit. Awesome to see. Now, this little teddy bear does have a lot of sentimental value. Now, this teddy bear went with me over to the University Rover Challenge back in the day. This teddy bear has gone to several challenges around the world. He has seen a lot of things. He's only been washed twice, I think, in 7 or 8 years. And he is a spaceman. And again, as a quick look over this system, that differential bar, that V-shaped, translating the forces between those two rear wheels. And then, of course, we've got these cylindrical motors powering the pivot steering of each of those wheels, providing a little bit of more functionality in terms of allowing that rover to translate its way across the surface in an XY direction. And this has paid a lot of dividends, as we saw in the post-landing task earlier on Thursday, where we got to see the rover reposition itself relative to the control panel, making it a little bit easier to use that robotic arm. And then, of course, you've got lots of 3D printed materials covering the surface of this rover, acting as interference or interfaces between all these different off-the-shelf or custom-designed systems. That hot pink folded sheet metal, all those cut-out shapes, reducing mass, but whilst retaining structural rigidity. Over to the front there, you can see that spoked aluminium rim holding in the motors there. Real novel approach in terms of, we've seen a lot of teams using 3D printing, but 3D printing the whole inner rim, outer rim, and tire tread. So it's good to see a team sort of breaking away from the mold and trying to integrate two different materials, really minimizing the mass and complexity of their system. And mounted to the very front, there may be a stereo cam, I believe, which provides a little bit of information in terms of the depth and sensing. Time is continuing to tick down. Up on the screen right now, some of the terminal information and camera feeds coming down from the rover. 30 minutes left for Nova Rover. So it's great to see a huge turnout from a lot of the teams supporting each other during their attempts across all the different tasks. So thank you to Nova Rovers for persevering through this brutal sunny weather. The umbrella's really coming in handy. And again, lots of people seeking shade, but these rovers being exposed to the brutal elements, much like what they'll really have to do if they are deployed to the lunar surface, but even more so because there is no atmosphere to help conduct some of that heat away. So all that illumination really building up on the system, causing the lunar surface to be almost 100 plus degrees during the day and then minus 200 degrees at night. A huge temperature differential that the robotic systems have to overcome. This is why a lot of the spacecraft that have been deployed to the lunar surface have really struggled. An example of this is the Chandrayaan-3 lander, which deployed one of the rovers, which survived for... And with that, it looks like the rover is attempting its autonomous traversal. And again, if it does touch one of those rocks, it does count as a collision. So 5 points, I believe, for leaving that start gate autonomously. However, 10% collision. But that's not to say that the team and the rover can continue to traverse across this course, and the rover making every move by itself here, all those wheels pivoting. Live decision making right now, we are witnessing an autonomous agent learning about its environment, being piloted by that teddy bear, the spaceman teddy bear, sealed away in his glass little beaker. And you can hear right now the crowd going absolutely ballistic with every single decision that this rover makes. It is a nail biter. The time is 3:27. The official start time was 3:15. Plenty of time for the Nova rover here. The Waratah rover to make its statement, make its claim of trying to see if it can improve the score that it achieved last year. And Nova Rover, of course, being the defending champions for 3 years in a row of the Australian Rover Challenge, that title under question, with Poland being absolutely dominant yesterday during the space resources task. Again, lots of points up for grabs here to see how far they can fly. And again, that individual pivot steering really being demonstrated here. The ability to traverse on a single dime. Really good traction control here, each of those wheels. And again, it does look like another collision. However, the suspension really being flexed out here today. That rocker suspension making light work of the wheels and the rocks. I don't know how many standards that driver has had, but it might be too many. So again, another view of the base station here. All hands off, hands in pockets, as this is fully autonomous. Again, this rover is driving completely on its own. Awesome to see. This is a demonstration or culmination of lots and lots of complex systems all working together. Not only do they have a rock-solid mobility platform, an amazing suspension and wheel tread, but right now you can see a little peek into the mind of the rover right now with that Linux terminal conveying all the information and the decisions being made. It's great to see, again, this little peep into what the rover team see in the base station, but as well as a little insight into the mind of the Waratah rover as it's making decisions right now, trying to traverse its way across these mounds, avoid obstacles, has already taken out a few of them. Again, you can see to the top left of the rover there, a little passenger. I'm going to have to check his license and registration after this task. It's look like the rover wants a bite of the action of this huge hill. And let's see if this will be one of the few rovers to traverse over it. Again, still getting traction, still maintaining traction as the rover makes light work of this hill. Wasn't quite all of it, but hey, we'll take it. And you can see a little shot of the underbelly of the rover. It is moving laterally, sliding down. Now, the key thing was it did not tip, it did not roll. It continued to move. And again, the rover is doing everything autonomously. All hands off keyboards. And if they're able to localize the location of these colored blocks out on the surface of the moon out here today, they will be awarded full points depending on how close their estimate of the X and Y coordinate of those blocks are to our true value, which has been measured and mapped by Cyro. And big shout out to Cyro for providing your expertise and LiDAR facilities for being able to map this whole arena in extremely high resolution and color. And such an awesome shot right there. The huge ground clearance of that rover really been optimized over several years of design and implementation. And it does look like with hands on keyboards, they may be transitioning out of the autonomous portion of their attempt. And again, plenty of time here. 22 minutes left on the clock. A lot of data being collected by these rovers. The aim of the game, mapping. And here we go, up on screen right now, a huge terrestrial sandworm. And again, this is the graphical user interface being displayed from the base station team right now. A little insight into the mind hive that is Monash Nova Rover in their mapping and autonomous attempt. Right now, the view up on screen is the GUI, the graphical user interface being displayed from the Monash Nova Rover team. And as is tradition, during this mapping and autonomous portion, a little bit of fun. And again, there the reference to the sand dune, the great grandfather sandworms of June. And again, right now, the team may be deliberating and sorting out the data that has been collected from that first initial attempt. And again, the rover was traversing a great deal of the surface completely autonomously. So again, huge shout out to the team working so hard, working really diligently late into various nights across the task here. You were some of the last ones to leave. So it's great to see all that hard work really paying off. The first one to blink loses. The local time is 3:36. We do have a passenger there awaiting his next instructions. Little spaceman teddy bear. Sealed away in an airtight enclosure of glass. Again, here's the front turret man of the Waratah rover, who has taken a lot of journeys at rover challenges around the world. And just about 20 minutes left for their attempt at the Boeing Mapping and Autonomous task, their last attempt of the 2024 Australian Rover Challenge, our fourth Rover Challenge. For those wondering why the rovers are moving right now, so we've just left the autonomous portion of their attempt for this mapping and autonomous task. The rover did leave the start gate successfully and autonomously before deftly smacking into a rock, causing a 10% point collision, traversing further out into the field, again, mapping autonomously. Now it does look there's a piece of debris next to the fake rocks out there on the field on its second collision. Again, here's the huge scale of the arena. Some teams have made their dent in that hill on the far right, trying to traverse it. Again, it's a huge 1.2 to 1.5 meters tall, significant obstacle, not only in terms of height, but also field of view for the radio antennas keeping and maintaining communications with the rover out there on the field, but also because of its high height and that angle of repose, that angle from the top of the mound down to the surface being extremely high for this material, meaning that traversal up it is really difficult, not only because of the angle of incline, but also the loose material that is accumulated on its surface and the sides, making it really loose and fluffy, meaning that any wheel not having full traction and large enough grouses just slips. And every time you slip, you have a little bit more wheel sinkage, and it's sort of this endless spiral, which leads to rovers becoming immobile and stuck. And if you ever heard of a rover being stuck, this is what exactly happened to the Mars exploration rover Spirit on Mars back in the early 2000s when it rolled into a really loose material called jarosite. And this material was almost cohesionless, meaning that as the rover dug into it, it lost all traction. The rover became stuck. Material accumulated on its solar panels, and it slowly lost more and more power and went to sleep, prematurely ending that rover's mission. Not only did it happen on Mars, but during the Apollo program, the lunar rover actually became stuck as it was trying to traverse nearby a large impact crater. And the astronauts had to get out and lift up the back axle and try and back it out of that material. So just little few examples of the issues of trafficability and maneuverability on these extraterrestrial surfaces in this regolith, which is just extraterrestrial soil, and we call it regolith as soil down here on Earth has a full ecosystem of bugs and organisms living within it. However, out on extraterrestrial surfaces, as far as we're aware, there is no life, meaning that it is just an accumulation of silicate minerals that have been crushed and weathered down from space weathering.
Oh, that's the picture we got. And it's still upright.
So up on the screen right now, a view of one of the placards that the rover autonomously took, which is the base station team trying to figure out what is on that placard so that they can relay that information to the judges during their judge presentation. And if you can figure out what that is, keep it to yourself, as the base station team can really hear us out here, which is why I'm really careful of what I say. Hello, base station team. And again, local time 3:41, Nova rover having started at 3:15, with a finish time of 3:55, just about 15 minutes left. The sun blazing down, umbrellas really showcasing their utility in both rainy and sunny days. And again, the rover is currently not moving, but for those interested in some more interesting space facts, did you know that the lunar regolith becomes electrostatically charged as the sun hits it with solar wind and radiation, meaning that the charge environment of the lunar surface changes from the day to the night, which means that as the lunar terminator crosses across that lunar surface, you can get dust electrostatically levitating off the lunar surface several meters. And this is actually what one of the Apollo astronauts described as a moonrise, as he was inside the lunar orbiter careening around the lunar surface. And as the sun rose above the horizon of the moon, you actually saw a sunrise as that light refracted through that levitated dust material. Of course, there can be no sunrise or sunset on the moon, as there is no atmosphere to reflect that material, which is why sunrise and sunsets look red, as all the blue light is scattered out. Another interesting fact, because the ultra-high vacuum conditions of the moon are so high, you can actually get a mechanism of cold welding, where different silicate metals can actually fuse together on cold temperatures because it's so atomically clean. And this actually caused the Apollo lander's door to almost become stuck with the Apollo astronauts out on the surface during one of their EVAs. Imagine being out on the lunar surface and you can't open the door to get back in. Quite terrifying. Now, up on the screen, it does look like a digital representation of the arena collected from the rover during that autonomous portion of the task. And again, great to see the team using this point cloud representation. It does look like that image to the bottom left might be the processing plant, perhaps. And what you're seeing live right now is the team going through the data that the rover did collect, processing it, cleaning it up, trying to localize it all together so that during the subsequent 10 minutes after 3:55, when the team are resetting the field, clearing out the rover and also processing the data for that 10-minute presentation, that they have a lot of solid data to go through and be awarded some really well-needed points. Just under 10 minutes left of Nova Rover's attempt at the Boeing mapping and autonomous task. And again, the team, base station team, right now, you can see a view into the base station tent, 8 minutes on the clock. Now the field team, of course, being ready. The base station team currently processing data, meaning that in each of the tasks, the team can be split up into a field and base station portion. The base station team responsible for interpreting all the data coming through the radio, collected from and by the rover, and the field team responsible for setting up the rover and packing it up, and also performing any intervention or repossessions required. And a view of that screen, trying to interpolate and review what the data they got and how is it valid, if they can clean it up or process it. Now, some of the teams have opted for stereo cameras, some have opted for LiDARs, some have opted for a fusion of the two. Now, there's lots of different tricks or issues that you need to overcome in terms of how do you manage the differences in illumination environment if there aren't enough features to provide physical texture in terms of understanding how far you've traveled. The benefit of LiDAR in subterranean challenges are, as you drive along and you map, you do have the whole tunnel surface to provide a context of whether or not you have moved, but out here on the surface, with the horizon and the sky above you, that's a lot of data that you're missing. Just about 3.5 minutes left in Nova Rover's attempt at the autonomous task, and of course Nova Rover being the last team to attempt this task. And as a reminder, we do have the award ceremony coming up after this, after we do have a little bit of a break, whilst myself and the other judges correlate and review all the different scores. So the award ceremony from 4:30 to 5 o'clock, followed by the fun and activities out here on the surface from 5 to 6. And just a bit of an update, just to confirm that the teddy bear mounted to the front of that rover has come face to face with 2 real black bears. Would you believe, in Yosemite Park, this bear is well traveled and of course sporting a very new and improved spacesuit tucked away in that little glass container, little passenger for the Waratah rover. Again, this teddy bear has gone to several different challenges over several years around the world, so it's great to see a little comeback. And again, 2 minutes left on the clock. The base station team right now continuing to process their data collected from the mapping phase, the mapping portion of their task, trying to localize the coordinates of each of those blocks that we've scattered out on the pitch. And of course the content of the placards that we've mounted onto the various locations around the pitch. And as we come to a close here on the last attempt at the Boeing Mapping Autonomous Task, a quick shout out to everyone who's tuned in across this live stream over the last 4 days. Thank you very much for tuning in and supporting the Australian Rover Challenge, and so many new teams coming out across Australia and the world. Quick shout out to Team Atlas from Bangladesh, travelling out here for their first attempt at the Rover Challenge. And of course, Project Scorpio from Poland, again returning for their second time at the Australian Rover Challenge, and boy have they done very well this year. Again, we still need a little bit of time to deliberate and confirm the final leaderboard, but once we do, tune in again at 4:30 for the award ceremony, and 10 seconds left for the defending champions, Monash Nova Rover, on their final attempt at the Mapping and Autonomous Task. Now, there will be 10 more minutes left. Big round of applause. Phenomenal effort for a sensational attempt at a fully autonomous traversal and mapping of the lunar surface. Now, 10 minutes for the team to do processing of the data they collected, followed by a 10-minute presentation. Again, for those wondering how you can get involved with the Australian Rover Challenge, well, if you're interested in joining or starting a team, please check out our website at Australian Rover Challenge. And if you're interested in participating but maybe in primary or high school, again, there are a lot of opportunities to get involved. Please contact your local university rover team or university who may be interested in performing some outreach. Lots of these teams perform outreach at schools all across Australia, really increasing that range of outreach and engagement in STEM education, but also highlighting some of the important skills beyond STEM, pathways like engineering or science, we've also got such an important need for media, people to communicate what they're doing and push it out to the public in terms of managing their time, their budget, making sure that the field operations and field tests are done in a smooth and operational manner, making sure the logistics are all done. Really, it does take a village to raise these rovers. And if you're interested in supporting that and you have a passion for space and a passion for exploration, please reach out. And we'll be back to you shortly in just about 33 minutes as we return for the award ceremony of this fantastic fourth installation of the Australian Rover Challenge. Thank you very much. My name is Daniel Ricardo, and I hope to see you very soon.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People traveled from far and wide to see this new city. We call it Moon Valley. The moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
This is where it started. And where you start. This is where you find a top 100 university. World-class research. And these little guys. This is where you study crashes. and become cancer smashers. This is where you crush it, cram it, glam it, and this is where you grow food for space. This is where your time begins. Make history at the University of Adelaide.
Una esquina que sí, una esquina de acá. ¿Sabes qué digo? O sea, cuando pones la otra cámara.
Oh, the setup, yeah. But hey, we left the
You won't make a lot of friends.
Yeah. What I love about that is someone like we're getting into it with someone who's both the time. Yeah, those are amazing. Muhammad's gonna be like,
Such a nice
then they scrolled down and it was that kid at the beach. It was like this. And then there was the Alex photo. Oh, really? What about the one where maybe 30 degrees. It was really trying. Like, just slowly checking it out. Yeah, it was sliding down sideways. I reckon you could actually drive up to it. You might slide down, but...
From Melbourne, I 5 minutes. Or maybe
This is genuinely so nice. It's like a vacation. Oh, it's so high. It's worse going back. Now we know what we're missing out on. Now now we know what we're missing out. We're still stopping.
I didn't let the camera in other countries. Oh yeah, I was like, invest in me and I'll move my car. I did not want to let them in now. I was being petty.
Yeah, but then you wouldn't have the game. Then it would actually be perfect. Then you could like you have to force people more to watch them, so then you could estimate how many points. We were talking about what if they so then people would have to like estimate. Yeah. But then people would do what we are.
Very good. Yeah, I saw the
When they do. It's so sad. was trying to get Emily.
I got shot.
I say that having
You gotta get another mic. Not here.
This will be a but it will, this will go.
You could submit the form and then the exact
Where am I? G'day, where am I?
Wait, you go.
G'day, where am I?
He already is.
What happened? It's you. That stressed me out. Beating each other.
With all the red eyes.
What are you saying?
Can someone speak?
Yeah.
Alright, let's get rid of this. Come back when we get That's perfect. That's perfect. Alright.
That's going on the okay, you're gonna put like an actual like this will be like
Hey team, can everyone start taking a seat on the stand?
Yes, sir.
Get a hat, please. You don't have a hat, get a hat.
No hat. No hat.
Or an umbrella.
You're rebellious, baby. You can see everyone was just like standing, saying like.
Is there like... I knew you were...
There's no proof that was my voice.
I got no team. We can do team photo over there, but team photo on this. Look, it's a so what should we do? Team photo.
Oh no, it's a bad aim.
We should do it now. Okay. On the stand. No, but what about that? What about that big ass hand? All the way at the other side. Yeah, where's everyone else? A lot of people around here.
I love it. Damn right.
That's the real one.
Yeah, alright. Can we send some pictures back to I don't know, but not everyone's here.
I saw this video on Instagram where like this and like if you close your eyes, it'll be like you're watching an episode of Monash and I close my eyes and it'll be like
Wait, where? We're not doing dinosaurs.
Oh yeah, did you send the voice message?
You on mic? Oh, hey, mate. Move that crowd right somewhere. Yeah. It's not long. It's not really long enough right now. That's the other cool thing. Yeah. What do you think? I just think it's on that side. Pointing like down. Okay. Maybe we do that after. As soon as the awards finish, we're not streaming. We're not coming up stream, but we're having the mic. So one of the team members sitting in the corner. But we'll watch, take the cameras. Oh, we can just have it where it is, sit in the stands. So we don't need to move it. We're not, no, we can't do that. Well, we don't need it over there. It's like singing. Everyone's scattered all over the place. Yeah, and also it's, yeah, I don't think it's, what do we do about team photo? So we can just post the award ceremony. I haven't checked it. There's no point. Adam, if you want to, we're not going on 10 yet. Take everything else. Damn. Man, could have had a gearbox in the center of that. Yeah. Oh, look at them do it. Yeah, is that a generator? Oh yeah, lead definitely. Biggest mistake. Most table-sized unit. Oi, you reckon it was rolled? Oh yeah. With a couple of cable-sized units. No, it's not going to want to. It can't go. It's going to hit camera. They're not going to want this. Yeah, take the camera off. Yeah, do we need a camera? You do need a camera. If we were to angle that down, oh yeah, the other camera currently is not very useful. Oh yeah. I mean, is this work? This one's also. Is that? Power. They're not connected. You enter the arena. You put the camera in and play it. These motors are connected. We could connect it up if we wanted to. Just the battles where you want to move it. I don't want to. Yeah. Cool. Oh no, we're going to do the top. These guys are left there. We're going to have to. We'll come back. I'm really happy that there's no amber. That's what it says in the wall. Very happy. Yeah. This is like the equivalent of like those like 36 playground. Yeah, I know. I hadn't even considered it. I was said, oh, so I hadn't even thought about it. I'm embarrassed to say I just thought I'd ask. Yeah, I bet. Oh, yeah. Inside there as well. Yeah, no, that's exactly what it's exactly. Oh, yeah. unplug the
We need a monitor.
That's crazy. I didn't realize
Help us out now.
I know what I did.
This is pretty good. Pretty happy with how it went last year.
I like the first that now?
Second year, we had third year, What do you think should a USB one? Not really. It was really good. I know. That's what no, so we take it, we transfer it across. And you don't get a ball. Yeah. There you go. Nice. Hell yeah. Nice. Yep. Yep. Nice. Hey guys. Oh yeah. Yeah, where?
also very scared that you know that that's a common class.
University of Melbourne. So we're going out onto the field now.
Line up, take a stand.
I just wanted to check.
Yeah, well, Aaron.
Alright, next year for autonomous journey, we're riding through to my before we come in, because I spent all afternoon pulling.
No, I said he's off doing geometry, don't worry.
The worst thing was actually because the points got changed every time, so, and it's like matching the colored blocks to the actual positions, and then cool. Alright, it's okay. In the end, I just went to copy that face. And in the end,
Yeah, you need to like saying they had a chat. Oh, they're actually
the only one that
So what you have built.
Oh,
yes.
Oh, so wait.
You have a 56. What you want is the maximum, but you've got maximum back on the you want the qualification you can is maximum back on the yeah, true. Yeah. So we keep a high drive, have the long term drive. I mean, if he's willing to watch it, if he's willing to front well, the main the footing, well, they take a train up to there, they go on a little lip, beaches. And so, I know where they're still at. I know where they are. They're in the back room.
Sun's in my eyes. Yeah.
Oh, yes. Yes, I know what I was
I texted my dad. I was yesterday, and I was like, oh yeah, well, I had a meeting. I only found out last night. And he was I want to say like, yeah, 21. Like a 5% gap. And maybe some of the things we said about the I mean, you're right.
That way. That way. Yeah, that one. There they all are.
I did.
Maybe sleeping until 7 tomorrow. I was like, I think we need to be here.
All right. Okay, good afternoon, everybody. Thanks very much for you being on time and having your rovers out here on time. First off, thanks so much for coming to the Australian Rover Challenge 2024 and putting on such a fantastic demonstration of engineering, skill, and expertise. So please give yourselves a round of applause. This was the biggest, the best, and the most complex rover challenge yet undertaken here in Australia. And the fact that you keep rising to the challenge is an incredible testament to the educations that you're receiving at your various universities, but also to the passion that you bring to this. And that passion has not gone unnoticed by all of our sponsors that are here. And then the entire staff has been commenting about that on top of everything else you're doing in your normal human life, you're doing this. You're doing this kind of amazing, cutting-edge exploration for the next space age. So we couldn't be more proud of each and every one of you and your creations that are here on the field with me. So, of course, this event would not be possible without the support of our sponsors. So I just want to one more time thank our premier sponsors, ELO2 and Boeing. Round of applause, please. Thanks so much. Our major sponsors, iSpace and the Australian Space Agency. Our supporting sponsors, the South Australian Space Industry Centre within Defence SA and Caterpillar. I think some of you may have seen the Caterpillar folks here. I can't quite tell looking at the audience, but you may have run into them. And our event partners, Mini Mammoth Games and CSIRO. Thanks to all of those sponsors for your incredible support to this event. All right, so without any further ado, we're going to hand out the third place trophy. And to help me do that, I would like to invite Eric Reiners from Caterpillar to the stand. Now, those of you who have been with us before may have noticed that there are two sets of trophies here. So in keeping with the tradition of the Australian Rover Challenge, we have these gorgeous creations that are the result of your past experiments that you decided to bring to the challenge, hot glue together and spray gold, and of course these ones you made with your hearts earlier in the competition, so those will be awarded. But in the past, sometimes the teams decided to make really, really tall trophies, and those were harder to take home. So we do have something that you can go home and show the professors at your university so they can continue to fund your trips here. So we have, thank you, Eric, some beautiful compact trophies for the teams to take home. So when we announce each of the winning teams, we would invite the entire team out here onto the competition challenge field, and then our sponsor will hand out the appropriate 2 trophies to the team members, and then we're going to get a picture with the whole team right here on the pitch. So without any further ado, I'd like to announce third place in the Australian Rover Challenge 2024, and that goes to UQ Space. Please come on up.
Is this the one we're looking at? Is that the one?
Come on up, team. You're part of this too.
I can hold this one. All right. Thank you, sir.
Everyone come in. Do we want the banner?
Yeah, you gotta have the banner. Gotta have the banner. Gotta have it.
All right. And
Somebody's taking this one?
that's right.
This one? Whoa, sorry.
Okay, so now one more picture here. We're going to transfer this trophy, Nelson, and then get a picture of the whole team. Awesome. Thank you. Great job. Excellent. Thank you. All right. Moving on. To help me hand out the second place set of trophies from Boeing, Glenn Gallagher. Please come on up, Glenn. So there might be two people on your team that would accept a trophy. So Glenn can hand one off to one team member, and then hand one off to another, and then we'll get a picture. All right. So in second place, 2024 Australian Rover Challenge is Monash Nova Rover. Come on up. Congratulations. Yeah, exactly. So we'll take a minute for the entire team to get up here.
We can hold that one.
Okay. Okay, so the executive team is here for this part. Okay. Okay, and now for the second trophy. Okay, and now the whole team, come onto the pitch. Yeah. Flood around.
You'll see me. So many people at the back. Just send on the table. Yeah, John, I get the table. That's the table.
All right, awesome job. Thanks, Monash, Nova Rover. Thanks, Glenn. Okay, and to help me announce first place, I'll be joined by ELO2's Ben Sorensen and Joe Kenrick. Please come up. All right. Beautiful trophies made by the students here. All right, so for the Australian Rover Challenge 2024, first place goes to Project Scorpio from Poland. Well done. Please come up. And now to hand out the student trophy, Ben Sorensen. Someone else take the second trophy. Awesome, fantastic job. Great job. Okay, we have a few more announcements, but before we get there, we have a request from one of our teams. So last year was the first time that the challenge was attended by international teams. This year, however, we had two teams actually make it to the challenge, and one of those teams has requested the honor of singing their national anthem here on the pitch. So we thought that was a great idea. That this event has been covered in their home country, and we'd like to honor them by honoring that request. So Team Atlas from Bangladesh, please come on up to the challenge arena.
Hello. আকাশ তোমার বাতাস আমার প্রাণে তোমায় আমার প্রাণে বাজায় বাঁশি সোনার বাংলা আমি তোমায় ভালোবাসি ও মা ফাগুনে তোর আমের বনে ঘ্রাণে পাগল করে মরি হায় হায় রে মা তোর মুখের বাণী আমার কানে লাগে সুধার মতো ও মায় অঘ্রাণে তোর ভরা খেতে কি দেখেছি আমি কি দেখেছি মধুর হাসি সোনার বাংলা আমি তোমায় ভালোবাসি কি শোভা কি ছায়া গো কি স্নেহ কি মায়া গো কি আঁচল বিছায়েছ বট মাটের মূলে নদীর কূলে কূলে মা তোর মুখের বাণী আমার কানে লাগে সুধার মতো মরি হায় হায় রে মা তোর মুখের বাণী আমার কানে লাগে সুধার মতো মা তোর বদন ঘানি মলিন হলে আমি নয়ন আমি নয়ন জলে ভাসি সোনার বাংলা আমি তোমায় ভালোবাসি
Thank you so much, sir.
Thanks very much, Team Atlas from Bangladesh. We really appreciate you honoring us with that. But we have another international competitor, and when they heard about this, they've also would like to sing their national anthem. So, Project Scorpio, come on down front.
Jeszcze Polska nie zginęła, kiedy żyjemy. Co nam obca przemoc wzięła, szablą odbierzemy. Marsz, marsz dąbrowski, z ziemi włoskiej do Polski. Za twoim przewodem złączym się z narodem. Marsz, marsz dąbrowski, z ziemi włoskiej do Polski. Za twoim przewodem złączym się z narodem. Przejdzie Wisłę, przejdzie Wartę, będzie Polakami. Dał nam przykład Bonaparte, jak zwyciężać mamy. Marsz, marsz dąbrowski, z ziemi włoskiej do Polski. Za twoim przewodem złączył się z narodem. Marsz, marsz dąbrowski, z ziemi włoskiej do Polski. Za twoim przewodem złączył się z narodem. Jak Czarniecki do Poznania poszedł z nim na wozie, dla ojczyzny ratowania wrócił się przez morze. Marsz, marsz dąbrowski, z ziemi włoskiej do Polski. Za twoim przewodem złączył się z narodem. Marsz, marsz dąbrowski, z ziemi włoskiej do Polski. Za twoim przewodem złączył się z narodem. Już tam ojciec do swej wasi, dumny zapłakany. Słuchaj jeno, polu nasi biją karawany. Marsz, marsz dąbrowski, z ziemi włoskiej do Polski. Za twoim przewodem złączył się z narodem. Marsz, marsz dąbrowski, z ziemi włoskiej do Polski. Za twoim przewodem złączył się z narodem.
So the Australian Rover Challenge is a equal opportunity event. And with our two international guests having had an opportunity to sing their anthem, this is not a requirement of the Rover Challenge, but we thought it might be nice to offer that opportunity to the host nation. If there's anyone from the host nation who would like to come up and sing the Australian national anthem, we have that opportunity. Not a requirement, and you weren't prepped because this all just happened. So, all right. Okay.
Good thing it wasn't me because I can't sing.
I don't think that matters.
We're gonna credit on the mic.
Well, we'll be up the front if we get the mic.
Yeah, of course.
Good. Second row, boys. Good God.
Actually,
No, they're up there as well.
Yeah, I'm gonna move this way because we both have mics.
Yeah, head that way. Oh boy.
Yeah.
Oh, this is real flat. Oh, no way.
I'm not confident.
I'm gonna do no stress.
we can crowd around it. Can we like hold it up?
What do you mean I can drink? Make the nation proud.
I'll try.
It's been a hot minute, I'm gonna be real.
Surely we're not the only ones on the microphone. Surely we're sharing.
We'll share it now. Australians, oh let us rejoice, for we are young and free, with golden soil and wealth of toil. Our home is girt by sea, our land of mountain ranges, our beauty's rich and rare. In history's page let every stage advance Australia fair. In joyful strains and let us sing, advance Australia fair.
Second
Oh boy. Are we doing the second part?
Beneath our radiant Southern Cross, we'll toil with hearts and hands to make the Commonwealth of us. Those of us come across the seas with boundless plains to share. With courage let us all combine to advance Australia fair. With joyful strains and let us sing, advance Australia fair.
That was something.
Thank you all.
Go ahead and stay on the pitch.
No, don't. Never go. Don't think. The worse the better.
Okay. Thanks very much. Appreciate you rolling with that surprise Rover Challenge event there, but it was fantastic. So thanks very much. We have a couple things left to do before we conclude the event and release everyone for the Rover Tug of War and Rover Hill Climb, etc., and then with dinner following at 6:30 in the hub. But before we get to the group photo, I just want to give some shout outs to the people who've actually labored for a year to bring you this event. So of course we've thanked our sponsors, and we do very much appreciate their support and being with us throughout the challenge. But we have to thank a lot of the individuals on the staff here and with some of the organizations who've helped us throughout the event. So Professor David Harvey, Professor Rini Akmiliwati, Henry Lurie, Dan Ricardo, Lachlan Holden. These comprised the technical expertise of the challenge: judging, narrating, student liaison, on-field problem solvers. A big round of applause for those folks that you're working with throughout the year to get you here. Some of them even deserving of screensaver time on the computers. So, entire event. Chelsea and the social media student team who've been going around conducting interviews throughout. Rosie Long from Marketing and Comms. And again, I'm just going to mention Mark Branson, who's the site manager here at Roseworthy, who found us all this space, configured the campus for the student tents and the lounge and everything else. We couldn't have done this without all of their support. And of course to the Andy Thomas Center for Space Resources and the staff there, Miles Davies, Jill Stewart, and the list goes on. But thank you so much. There's no way we could do this without, yeah, okay. Thank you. Okay, so we're about to come up here for a group photo. We know that these are you're proud of your babies here, so we're going to go ahead and get everybody to line up in a semicircle behind the Rovers, and then we're going to get a group photo. When that is done, you're going to be out here on the pitch. There's going to be a little bit of bedlam ensuing, so we're probably not going to sit back down in the stands. So I'm just going to say a couple of announcements right now. So there was the Caterpillar QR code drawing competition. We have 3 winners. I'll just announce those very quickly. Eric, with your permission. All right, so Yvette Wen, Sienna Zubchik, and Rahal Chatley, you have bags that Eric has right there at the down front. So congratulations to those 3 winners. And thanks to Eric and Caterpillar for that. Okay, after we take the picture, we're all going to be looking at Nelson, and when he's happy, then we're going to be done. And then we can get on with the tug of war, Rover Hill Climb, etc. out here on the pitch. We'll see who can actually catch some air off of our crater walls. My money might be on Team Atlas from Bangladesh. And then dinner at 6:30 in the hub. So with that, thank you so much. That's the official end of formal ceremonies. Come on out here and let's get some awesome group photos. This picture is for everybody. So student competitors and the staff, everybody who helped out. So if you're on site and you were part of Rover Challenge, please come onto the pitch. Students, sponsors, anyone supporting the event, you're all coming out here. This includes sponsors,
We're jumping in the photo, are we? Hey? We're jumping in the photo, are we? That's what Neil said.
Who are we looking at?
the gentleman in the red shirt.
Silly one.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People travel from far and wide to see this new city. We call it Moon Valley. The moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
Since opening our campus 150 years ago, we have constantly evolved. From our first pioneers in gender equality, we have inspired a new generation of leaders. If we saw closed doors, we'd be first to burst through them. As we have evolved the world around us, helping our students reach new heights. We have given shape to the laws of nature and the nature of our laws. We have helped preserve ancient languages while breaking new ground with the written word. Although we are proud of what we have achieved, we remain resolutely focused on the future. By continually becoming the change we wanted to see, the University of Adelaide has evolved into one of the world's leading universities. Because by making history today, we will build the world we want for tomorrow.